Good morning to participants. Each screen
Very good morning to all. Good morning to the participants. Today in the morning, we are starting with the first session with our Professor Krishna T. Kumar sir. Our chair will be Dr. Harshavardhan. So I'm happy to introduce Dr. Venkata Harshavardhan. So formerly he is in Time Business School. Now he is in Dean, AM Jain Institute of Management and ABIP. Sir, he has had his PhD from SU University with OR in Management and BSc in Agriculture. He has a double post graduation in Management, and he has been attended Winter School at IIT. He has got 23 years of teaching experience academic, also with 10 years of corporate experience. So he is famous for corporate training in Malaysia, Thailand, Egypt, to International Federation of Training and Development. I'm happy to introduce Harshavardhan sir. I request you to take it.
Thank you, Saran. Good morning to all of you. Sir, it is my privilege to introduce you. Dr. T. Krishna Kumar is an independent consultant in business analytics, and of course that is my field, and I'm very happy to associate with you, sir, through this interaction. Then his recent academic position was in as a adjunct faculty in Department of Statistics, George Washington University. That is in Washington, D.C. That is between 2012 and 16. But prior to that, he was a faculty in many USA-based and Indian-based B schools as well as Department of Statistics. And he has got so many years of experience with George Washington University, and that is between 2000 and 2016. And finally, I just want to give a brief note about his experience. Dr. Kumar obtained graduate training and for mathematical physics from Andhra University, Balter, and Indian Social Institute, ISI Calcutta. He has pursued his PhD in economics from Iowa University also, USA. Then doctoral thesis is on models of optimization and control in the theory of economic policy. He was awarded postdoctoral fellowship by the Central for Research Management Science, University of California, Berkeley, California. Of course, he has got a wide variety of teaching and training consultancy experience. Now it is my privilege to hand over the session to Dr. Krishna T. Kumar. Thank you. Thank you.
Participate in this conference in honor of Dr. P.R.R.RAO. His Centenary was celebrated recently, and I do not know if most of you participated in it. There was a Zoom session, cake cutting of his 100th birthday celebration, which I had organized, and I wished him my best wishes on that day, and I take the opportunity to wish him again more years of healthy, happy, and productive years for him. And it is in fact a sign of my gratitude to him for making me an econometrician that I do all these things. He is very, very responsible for what I am today. And thank you very much for giving me this opportunity. Originally, I thought of talking about quantitative economic issues and the contributions made by Dr. Rao to quantitative economic policy issues. But that is a topic I am still working on. It is incomplete. So I approach to quantitative economic policy modeling. That is what I am going to talk about. And it more or less traces continuously from my doctoral work to what I am doing today. It is all related to quantitative economic policy, and I'm going to explain what I am currently doing in relation to what I started with. In fact, if one looks back at the history of development of econometrics, first two Nobel laureates in economics, John Tinbergen and Ragnar Frisch, both of them were visualizing a social engineering approach to economics. So for that, in order to have a social engineering approach, they needed an econometric model. Are you able to hear me? Are you able to hear me? Are you able to hear me?
Sir, it is audible. It is very much audible.
Okay. I want to make sure. So they started with quantitative economic policy models from a social engineering perspective because they wanted to understand the economy, they wanted to predict the future course of the economy, and then they wanted to control the economy to go in the desirable direction. So as a result, it is that. And if you recall, the second 5-year plan developed by Professor Mahalanobis, that was also a kind of an operations research model for Indian economy. So what Mahalanobis did was, he took an objective function, that of doubling the national income, and then he used a dynamic model of the economy, full sector model, and tried to find out the optimal policy solution. So again, that is an operations research problem. So when I started my doctoral work, what I did was I started applying the then nascent or new optimal control theory to a policy problem, economic policy problem. So the analogy is quite similar between optimal control theory and economic planning. In optimal control theory, what they do is it is developed because of the space research. They take a space vehicle at a low level on the ground and they want to position it at a very high level in the universe, and they would use certain controls like the amount of fuel and where to fire the second stage rocket, third stage rocket, and so on, how much fuel to use. Those are the control variables to steer the direction of the space vehicle to the ultimate target. And in economics also we do more or less same thing conceptually. We take an economy from a very low level to a very high level of development, and in the process we try to use certain controls like government expenditure and how much to allocate to various sectors and so on are the controls. And so optimal control theory is actually applicable to economic planning models. So that is what I did for my doctoral thesis. And then after working for several years in the USA, I returned to India in '78. At that time, what baffled me is that a lot of people were working on poverty, but there was a poverty in poverty studies. And all of them use what is called a poverty line, which is arbitrary. For someone going from science, because my background was mathematical physics, and then went into statistics and then economics. So for someone like me with my background, the concept of an arbitrary poverty line was something I couldn't really accept. So I looked at the literature and I found that there was no need actually to use a poverty line. Not only that, by using the poverty line and studying poverty, people were actually measuring not poverty. They were actually measuring the income inequality of the people who were below the poverty line. Income inequality is not poverty. Poverty is a deprivation in consumption of essential goods like food and nutrition, for nutrition. So I was very unhappy with that. So myself, with the help of another friend of mine, who happened to be actually a biochemist working at National Institute of Nutrition, and he and I, along with another statistician, Professor Ajay Gore of University of Pune, all three of us worked for about 3-4 years on developing a nutrition-based poverty without a poverty line. And the original thought, the idea was from my friend Professor V.Sitaraman of National Institute of Nutrition, and I gave him a helping hand, and we developed a measure of poverty. That was published in Journal of Statistical Planning and Inference in 1996. Then for several years I did nothing on poverty also. I switched to management and doing some other things. Then a former student of mine from India, who was at that time London School of Economics, University of London, he suggested that microdata is available from National Sample Survey Organization, so we should return to that topic and work on it. So he and I worked on the same concept using the micro level data and published a paper in Journal of Development Studies in UK. And then a very interesting thing happened. My student happened to develop a friendship with a physics professor in England, UK, and his own Professor J.K. Chattopadhyaya. He's at one of the UK universities, Birmingham. He is at Birmingham. And he and my student Sushant Malik, they had written a paper, very interesting paper, and applied that kind of a logic to estimate poverty. And that paper dealt with what is called an agent-based model for exchange of goods and services. And that intrigued me very much because all along what was happening is people have been studying poverty without relating poverty to the general economic phenomena which generates that poverty. If you really want to alleviate poverty, you not only have to measure poverty, but you have to find out what generates that poverty. And that requires an understanding of the economics that generates poverty. So this agent-based model was very, very ideal for that. So the moment I saw their paper, I also showed interest, and three of us, that is Amit Kumar Chattopadhyaya of UK, and my former student Sushant Malik, and myself, three of us worked on poverty without a poverty line. And before I explain that, let me mention very interesting development within the poverty. The wrong direction that was taken from 1901. But in 1857, much earlier, a famous statistician and an economist by name Ernst Angel, he developed poverty measure based on household sample survey data on consumption. And the way he did it was much more appealing to me, which I came to know much later. After we did, independently we discovered the same thing, Sitaraman, myself, and Anil Gore, and S.A. Parajpe, four of us, and J.G. Shastri, 5-6 of us. We all developed a paper published on poverty in Economic and Political Weekly, in which we did more or less the same thing that Ernst Angel did. So let me talk about Angel's work. What Angel did was, he looked at a hierarchy of needs by consumers. So he said, at very low levels of income, people would like to consume basic essential food. Once income grows a little bit, then they go to other exotic foods. And once income goes even further higher, then they go to some non-food items, and so on and so forth. So he had established a hierarchy of needs, and then he identified that food was the most important element in consumer basket. So he concentrated on food consumption, and then he argued that food consumption reaches a saturation, and that means after a particular level of income, even if income increases, you don't consume any more food, but you would rather consume other items. And any shortfall of consumption, food consumption, from the saturation level, he called that deprivation, or we called that deprivation. He only analyzed relationship between income and demand for consumption of food. That was Angel's work, based on a hierarchy of needs. What we did was, we did that hierarchy and then identified the maximum consumption, and then called the shortfall from that maximum consumption as a consumption deprivation. And then we showed that consumption deprivation is a better measure of poverty than an income inequality measure that was being floated all around. That was our contribution in 1996. Unfortunately, what happened, that study of 1857 was in German language, and in 1895, Ernst Angel was also the founder of International Statistical Institute, and they had a bulletin, and he published in the first volume of that bulletin, he published an English version of the same paper. So, no, not English version, German version he published in that paper. That is an international bulletin. It was later translated in someone in the Agricultural Department of Agriculture. So, that is the reason Angel's work was not known, because it was not in English language for a long time. And Angel's work was only essentials of Angel work entered into economic textbooks, but the original work on poverty studies was not made available to us. Then what happened in 1901, a British economist, he started working on poverty, and for that he used poverty level of income, and he said he would focus only on those households whose income level is equal to poverty level of income or less, and they are the poor people, and he would study their consumption pattern. That is a person by name Roundtree. So he did the studies like that. Then he had set the stage. Everybody after that 1901 study of Roundtree started measuring poverty by defining a poverty line of income, and then saying everybody who has an income below the poverty line income is poor. And then the first was they counted the proportion of poor. How many people are below the poverty line? Then somebody said, no, that's not a good measure. You need to know how poor they are. So in other words, you have to see by how much that income shortfalls from the poverty line, and what is the distribution of the people according to the extent of shortfall from the poverty line. That is how people studied poverty. But unfortunately, almost all those studies looked at poverty as an income inequality. There was no relation to consumption of essential goods, which was the original idea of Ernst Angel. So whereas our study, we also in our study published in Economic and Political Weekly, we use national sample survey data, much larger database than Ernst Angel. For the first time, we developed a hierarchy of needs. We found that the cereal consumption is the most essential one. Next comes fuel, cooking fuel. Naturally, nobody can cook any food without the cooking fuel. Kerosene for the rural people. So, like that, we identified numerically using national sample survey data the hierarchy of needs. So our paper focused on hierarchy of needs. That was very interesting, and how that hierarchy has remained stable from one round to another round of national sample survey. We did all that. And then what happened was, coming back to the traditional studies of poverty, that Roundtree set the stage for poverty measurements. Then in 1973 and 76, around that time, Amartya Kumar Sen, the Nobel laureate of economics, Indian, he came into the picture of poverty. So he developed a measure of poverty based on an axiomatic approach. In my opinion, his paper had done much more damage to the concept of poverty line than others, because what he did was, he took that Roundtree's notion of a poverty line income and he axiomatized. So his development of an index was supposed to be more sophisticated, more mathematical, more abstract. So the moment we have more mathematics, more abstract, more axioms, people consider that to be very scientific and more respectable. So he gave the notion of a poverty line, gave much more respect than it deserves by accepting it and then making that as one of the axioms. And axioms are the ones which normally you don't question. Okay, you take them to be obvious truths. Okay. But unfortunately, it is not really essential for measuring poverty. So what he did was, he said, one of the axioms of Sen was focus axiom. He said, in order to measure poverty, you have to focus on the poor. So how do you focus on the poor? You have to define who the poor are. How do you define who the poor are? You say those whose level of income is less than the poverty line level of income are the poor. So he formalized it. So from his contribution, which is one of the fundamental contributions in poverty studies, the poverty line has been crystallized. So that is the reason. In fact, when we wrote that paper, which was published in Journal of Statistical Planning and Inference, published in '96, we submitted to that a very good economics journal called Journal of Development Economics, coming from University of California, Berkeley. It was rejected by saying, how can there be a poverty measure without a poverty line? It's unthinkable. That is the attitude. But we had fought over years to uphold our view. I have been continuously working on this issue of poverty without a poverty line for a long time. So coming back to our study, we did this poverty measurement without a poverty line, and we took three of us, that is Chattopadhyaya, myself and Malik, we three wrote a paper, and in that paper, the agent-based approach and applied it to the poverty measurement. And that agent-based approach is as follows. Look at an economy. Economy has different economic agents. What are those agents? For example, there is an unskilled worker, there is a semi-skilled worker, there is a skilled worker. There are people who are wealth holders. They don't work. They don't do a job. They have a lot of acquired health from their ancestors. So they invest that in physical assets, in financial assets, and those assets give them some return income, and that income is legal. And like this, these are the agents, these are the economic activities. And what we do in our work is that we assume there are a large number of agents, economic agents, say in the labor market. In unskilled labor market, there are a lot of people, unskilled laborers, whose only resource is their ability to do physical work. So they offer to do physical work, and in exchange, they get some wages. So that is the exchange taking place. The workers offer their labor, and the employer gives them wages. And there are a large number of workers, and there are a few employers. It's the labor market. Now there is another market which consists of semi-skilled laborers, where semi-skilled laborers offer their work which is better than unskilled workers. They get a little bit higher wages. And those wages, semi-skilled labor as well as unskilled labor, their income may not be adequate to meet all their expenses. Then there are others who are skilled laborers who exchange their labor and get an income salary. And that salary may be more than what they can spend. Then there are wealth holders whose income from capital gains as well as from the return from investment much larger. So these are all the exchange markets, and there are in each market there are a large number of traders, and usually those who accept in the asset market. In the other employers would be smaller in number, and employees would be very large in number. So this is the kind of mechanism. So what we assumed in our paper was that this agent-based model works in a very logical way. The way I have just explained, that is the market mechanism. But we assume that there is a behavior pattern. It is we also say an eco-behavioral model, sense that all the people operate in this agent-based model in such a way that they look at their own community to which they belong. So for example, the unskilled laborers look at all the unskilled laborers among whom they live. And they all have a particular lifestyle, a consumption pattern. So they all try to emulate the average behavior pattern of that community. But at the same time, they would like to advance a little bit, try to improve, try to get out of that kind of a narrow network and maybe become semi-skilled workers. Similarly, the semi-skilled workers may want to become skilled workers. So they all want to remain within that kind of a community to which they belong, but at the same time want to improve a little. So that's the assumption we make, that people try to improve from the previous condition. That is what brings in the dynamism in our model. So we assume this, although the exchange takes place, that exchange model has a dynamism where people try to advance, but not all of them can advance. Some can increase their income, but some may fall back because of other circumstances. So our assumption was that there is a common knowledge to all these people. That common knowledge is they observe people and know how they are spending their own community people, how they are spending. That common knowledge. We assume that common knowledge nobody cannot quantify, but we assume that the actual data that we observe, if we look at patterns in that particular data, whatever patterns we get statistically is intuitively a common knowledge pattern that people have. That means at this level of income, consume so much of food. That is the common knowledge. And we assume that the actual consumption deviates from the common knowledge and expectation by a certain amount, and that is stochastic. And that has a Brownian motion. So we assume a dynamic model of consumption and income, where that dynamism is brought by people's aspiration to stick to the community level and higher, plus a random term. And that kind of a model is equivalent to what they use in physics, a Brownian motion kind of a model, and that gives rise to what is called a Langevin model. And the solution to that would be what is called a Fokker-Planck equation. That's the contribution of our physics friend. So he had developed those models, and he had written a computer code to solve them. And the solutions were used. They were mapped using the National Sample Survey data for India, and we found wonderful fits of consumption expenditure on food and cereals, and also of total expenditure, which is a proxy for income. And we found excellent fits. We use them, and we use that consumption to find out what is the saturation level. And once we know the saturation level, we know what is the shortfall from the saturation level, and that is the consumption deprivation. And that consumption deprivation measures poverty. So using this dynamic model, we were able to calculate poverty, and also we were able to predict the poverty level using our model, because it's a dynamic time series kind of a model. So that was the work which he did, and it was published in 2017. And by this time I have also developed an interest in publishing not in economics journals but in other journals. So it was published in, that it saves us time, because economists can't accept some of these things that easily. They're all confined to a particular mode of thinking. So physical reviews published by the American Physical Society, because the model we use is a physics model. And that was published in 2017. Realized that what we were doing is really a social engineering kind of work, in the sense that we are quantifying, we are describing the dynamic model, and we are predicting how the poverty level will be given time series data. Okay. The next step would be, we need to know what are the factors in this exchange mechanism rise to low levels of consumption. And if we know those factors, what factors contribute to low levels of income, then we will be able to affect change through policy some of those factors so that consumption levels would drop, they would rather increase. Okay. Policies such as a better distribution mechanism, policies such as more fertilizer production, or maybe not using fertilizers at all. Sometimes they have a long-term damage. And cropping pattern, maybe a better cropping pattern so that the poor people's food is produced more than rich people's food, things like that. So if you do that in our model, then it becomes a policy engineering model, an engineering model for policy. So that is what we are now planning to do. But when we do that, what we have to do is we have to add a policy objective function. Okay. Once we have a policy objective function, we have to ask, first of all, how do you measure a policy objective function? Again, that is a work that I had done along with a PhD student of mine in Florida, where we tried to develop a policy model for allocation of resources within a university, allocation of resources between teaching, research, and public service. So for that, we needed to know what are the university's objectives between these three, teaching, research, and public service. So my student went and interviewed the Vice President for Academic Affairs, who also happens to be an economist and a friend of mine. So she went and interviewed him. Say for example, what are two levels of teaching allocation and research allocations that he considers are equivalent? So then you get what are called indifference curves. That means the indifference between this amount of teaching and this amount of research. Trade-off. So from those, what we did was we were able to map indifference curves, different indifference curves. Lower indifference curve is lower allocation of teaching and research, and higher indifference curve is higher allocation of teaching and research. Teaching is on one axis and research on another axis. And a bit higher indifference curve is even higher teaching and research and so on. And then obvious that those combinations on higher and higher indifference curves have higher preference. And the way to measure that is you take a line, a diagonal line from the origin, cutting across all those indifference lines, and the distance between origin and the indifference curve would be a measure of preference of that particular indifference curve. So if you go to the higher indifference curve, the distance is higher, so it is a higher preference. So using that, we measured the actual distances of those mapped indifference levels from the origin and quantified that as the amount of preference, and then estimated a regression relationship between that estimated preference level and the levels of teaching and research and public service, and obtained a beautiful regression relationship between the arguments, teaching, research, and public service, and the level of preference. And that is how one can objectively determine the preference functions through an interview method. So we did that, and that was unique. I haven't seen that anybody do that. But later, much later, I found out that the same Ragnar Frisch, who founded econometrics, did that much before anybody. So I realized that much later, after myself and my student had done that. So now so we have to superimpose an objective function, a set of dynamic equations and then come up with a solution to a dynamic optimization problem. So it is like optimizing a time-dependent function, which is an objective function, subject to set of differential equations which describe the model of the agent-based activities of exchange model, subject to some initial conditions. So you optimize that. That is an operations research model, which is the next step we are planning to do for poverty alleviation. So if you want to reduce poverty, and your poverty reduction also means sometimes you have to take resources away from some other investment. So the government, when it concentrates on poverty, there may be less growth. So there will be trade-off between the growth of the economy and the poverty reduction. So you have to find out what is the proper objective function between the two arguments, put that as an objective function, put the poverty model we already developed as the constraint, and obtain an optimal solution for poverty alleviation. This is what our next step is. We are planning to do that. And these are not enough. For example, when Professor Malar was the operations research model for planning in India, the assumption was that India wants to be self-reliant, so there is no question of dependency on foreign countries, and hence all our planning is internal. So there is only one objective function which we try to maximize, that of the government or planning commission, and one economic model for the country. But later, the things have changed. We have open economies, free trade regime, and so on. And then monetary policies have to be coordinated between countries. Exchange rates have to be matched, and we have to monitor. Even all this, what is needed is that each country will have its own objective function. So India maximizes its preference function, and the United States maximizes its preference function. But both of them are engaged in trade, let us say. And the question is, what one gains, the other may lose. So sometimes conflicts arise. Those conflicts have to be sorted out. Maybe some coordination has to be done. So all those concepts, the right type of operations research model for that is game theory. And particularly if the models are dynamic, they are differential games. So to illustrate that, in 2010 I had presented a paper at a International Operations Research Society meetings at Lisbon, Portugal. And that paper is an application of differential game theory to multilateral coordination between countries and macroeconomic policies. Would be fiscal policy, monetary policy, trade policy, all of them, in order to negotiate between countries what should be the
Yeah.
5 more minutes. 5 more minutes.
Yeah, you can go ahead, sir. No problem.
So I explained using differential game theory how some of those issues can be tackled, and same thing we have to do in our poverty model also. If we want to apply, if we find that there are different groups within the country, and each group has its own objective function, like the poor and non-poor. So what is the poor people's objective function? What is non-poor's objective function? So we may have to have some game theoretic dimension to this problem also. So I'm just illustrating that these are various ways in which operations research models are used in economics to address various economic policy issues. And that has been an area of my work. All this came from the studies at the Indian Statistical Institute, studies under Dr. Rao, and also inspiration got from Professor P.C. Mahalanobis, his work on planning using operations research tools. And this is what I would like to talk about, explaining my own work on quantitative economic policy, the role of statistics, economics, and econometrics, and the stochastic nature of our dynamic model, etc. So I thank you, Professor Rajshekhar Reddy, for giving me this opportunity.
Yeah, sir, it is our pleasure to have such a presentation.
I wish the rest of the conference a great success. Thank you.
Yeah, we are really blessed to have such a nice presentation, sir. Thank you.
Thank you.
And can I ask VIBHUSHAN or delegates to take some clarification?
Yeah, sure. Sure.
Even is Dr. Lavanya Kumar is there. I think she can raise some doubts if at all she needs any clarification. Professor C.S. Lalita Madam is also there.
Yeah, Lalita.
Miss Monisha is there. Yeah. If you have any doubts in the current presentation, we can take some 3 to 4 minutes time. Yeah, go ahead, ma'am.
No, thank you. I don't have any question. I heard. Thank you. It was great to hear, actually. So at this moment, I don't have any question.
Yeah, please, I will do one thing. Please note down my email address, tkkumar@gmail.com.
Sure, sir.
If you have any questions, please feel free to ask me. And some of my papers have already been mentioned in my PowerPoint presentation that I had shared with Dr. Professor Rajshekhar Reddy. So you will get them from him. Okay. And actually, I'm going to send an updated list of references within the next hour or so. So that will be useful to anybody who wants to follow this line of work. But there is a great potential to work in this area.
Yeah. Yeah. Thank you, sir. Thank you very much. And it is my pleasure to give a formal vote of thanks to you.
Thank you. Thank you very much. I enjoyed it very much. Yeah.
Yeah. And we are very happy to have your lecture, sir. And Dr. Rajshekhar Reddy sir is here. We just want to give a thanks.
Thank you, sir.
You're welcome.
Nice presentation. Yeah. Very happy to see you, sir. Okay. Thank you, sir. Thank you for your nice presentation.
Thank you. And I'm signing off.
Yeah. So it is my pleasure to invite one more resource person for today's presentation. I'm inviting you, Professor Lalita ma'am, and I'll just take 3 minutes of time to introduce her. She is a professor in Department of Mathematics, University of Delhi, South Campus, and she is also head of the department. And one more feather in her cap is the Dean of Faculty of Management Sciences in prestigious University of Delhi. So I just want to add one more thing. She is an awardee of Indian National Science Academy in 2016, especially for teachers in science stream. And she is specialized in optimization various inequalities and convex analytics and non-smooth analysis, if I'm right. Then she has published 3 books and almost 60 papers in various rated journals. And she has also supervised many PhD and MPhil students. With this brief introduction, now I would like to hand over the session to Professor Lalita ma'am.
Good morning, madam.
Good morning. Good morning.
Good morning. Hello. How are you, madam?
I'm fine, and it's really a privilege to be a part of Professor C.R. Rao's birth anniversary lecture, and I'm also thankful to you for inviting me for this. And I'm sure that this will be a grand success, and you have been organizing successful events, and this also will be one of the most successful event. And hope to see you organizing many more such webinars in the coming days. Thank you, sir. Thank you.
Thank you.
I would like to make PowerPoint presentation. Can I do that?
Yeah, you can go ahead, ma'am. No problem. You can insert.
Okay, I'm trying to do that.
You can share your screen, ma'am.
I'm just trying to do that. There seems to be some little problem.
Otherwise, you can send the PPT to me, and from here I can organize. That is also easy.
I do that. So I'm just sharing it. Can you see it?
Yeah, we can see that.
Yes.
Okay.
Very much.
Okay. Thank you. So mine is more of a theoretical work. I don't know how many of people around there are from the theoretical background, but I'll try to explain the things what is being done over here, because it is the concept of stability, that too not in scalar optimization but set optimization. So there are 2 things we have to keep in mind. What is the meaning of stability? There are various types of stability, and how the stability is being applied in the set optimization area. So starting with stability, which is seen in many places, like it will be optimization, be it a stochastic optimization, or you talk about game theory, everywhere you see stability. So what it means is that if there is a problem and we want to solve it, we of course cannot model it exactly. So when we model it, there is some slight change, there is some modification, or some sort of uncertainty may occur into the system. So when we solve that, we want to see whether the solution which we have obtained is actually converging, or is it nearby to the actual solution of the original problem. So the stability is a very important concept, and one has to understand what is stability. There are various ways of stability which is being discussed these days. One of them being that you talk about the solution set of the particular problem, and we want to see whether that solution set converges to the solution of the original problem. Another possibility is you talk about the continuity aspect, whether it is continuously moving towards the optimal solution of the original problem. So these are the basic things we have trying to study in the area of set optimization. Let's try to consider a simple optimization problem. Let us say we have a function minimize fx is equal to 2x square, and it has to be minimized on the interval 1, 2. So only in the interval 1, 2. So we can see that this function will have a minimum at x star equal to 1, and the minimum value is fx star equal to 2. Now, there are 2 concepts of stability which I'll be talking about in this external and internal in the set optimization area. But before that, let's see what that actually means in the setting of a simple simple optimization problem. Sorry, it is minimize fx is equal to 2x square. It's not x square, 2x square. Let us say we perturb the feasible region was 1, 2. 1 to 2, the interval 1 to 2. Now let us say there is a small perturbation only in the feasible region. There is no perturbation in the objective function. That means the feasible region is going to 1 minus 1 by n and 2 plus 1 by n. And as n increases, we can see that this set somehow goes close and close to the original set S, 1, 2. It goes to 1, 2 as n tends to infinity. Now, under these conditions, what is the optimal solution of this problem for this function 2x square? It is attained at the least point, that is 1 minus 1 by n, and minimum value is 2 times 1 minus n square. And we can see that xn star goes to 1, this goes to 1 as n tends to infinity, and this also goes to 2, this is actually 2, it goes to the objective value of the original problem. So what is this external stability? We have a problem, we have corresponding families of problems. If we we try to find out the optimal solution of the this particular family of problems, and we want to see whether that solution is actually converging to the original solution of the original problem. So this is external stability, because stability is coming from the associated problem. We are starting with the optimal solution of the associated particular problem and then going to the solution of the original problem. It is going towards one, which is the original solution of the original problem. Now, internal stability is the other way around. It is you talk about the optimal solution of the original problem and try to see whether it can be approached with the help of optimal solution of the problem. In external stability, you're talking with the optimal solution of the particular problem and see whether it's converging to the original solution. Here it is, you're starting with the optimal solution of original solution and then try to see if there are optimal solutions of the particular problem which will converge to the optimal solution of the original problem. So these are two types of stability, and in this problem we can see it is internally stable, externally stable, and it is so because the function involved is very good. It is a continuous function. So whenever we have a continuous function, some compactness assumption, everything works on smoothly. But when we go from scalar optimization to set optimization, these concepts of continuity, these concepts of convergence have to be thoroughly investigated. It will be in a different setting. Has to have some different way of understanding these concepts. So this is the difficulty when we talk about set optimization problem. I'll also show you an example where this stability fails because, of course, the function is not continuous. Let's say we have this function fx is equal to x when x is negative. So this is the graph, and it is 1 minus x. This is the graph when x is greater than or equal to 0. And let us say the feasible region is 0 to 1. This is my feasible region. So in this feasible region, you can see the function is like this, and the minimum is attained at x star equal to 1. Now, if we perturb it a little bit, the feasible region is from now minus 1 by n to 1. So that means I have a little bit over this side. Then what happens? The minimum is now attained at this point. At the point, say it is n is equal to 2, then it is minus half to 1, and the minimum will be at this point, at x equal to minus half. Then I make it minus 1 by 3 to 1, then it will be minus 1 by 3. Now, what happens to these minimizers of the particular problem? It's minus 1 by n. But minus n by n, where is it converging? It goes to 0, but the optimal solution is sitting at the point x star equal to 1. It is not going to the optimal solution of the original problem. The difficulty is because there is a discontinuity. Things are not happening the way we want to happen. Similarly, this can also be seen that the external as well as internal stability, both of them fail. If I start with this point, then the optimal solution of the original problem cannot come to the optimal solution of the original problem. Neither you have external stability nor do we have internal stability. Now let's go to set optimization problem. So what is the difference between scalar, vector and set optimization problem? Is that the objective function are in the form of a set. That means at each point x you have a set. Let's try to understand that. If we have a metric space, let me associate. This is the setting we have taken because our results work in this setting, but it can be any space. X can be any space, y can be any space. So we have taken x to be a metric space, y to be a norm space. Now a set valued map is associated. What we mean by set valued map is corresponding to each x you may have a set. The set can be singleton, it can be an infinite set, it can be an empty set also. But of course, empty set is not going to make any sense. So ultimately, we focus ourselves to functions which are defined in such a way that there is some point in the set. That means the collection of those points are called domain of f. The domain of f consists of all those x in x for which f of x is non-empty. So this will be a setting which I may not have mentioned explicitly, but this is how the things will be working in this setting. So what is a set optimization problem or a set valued optimization problem? Is I'm taking a very, very simple model where we have minimized a function f, where f is a set valued map. So when you put double arrow, it means the set valued map. So that is the notation, standard notation for set valued map. And S is a subset of X. Now, the particular cases are if it's a single valued optimization problem, that means it is do not go from X to Y, but it's only going to one point. Rather than a set, it becomes a vector optimization problem. If suppose Y is R and it is single valued, then it becomes a original scalar optimization problem, one of the examples which we had heard earlier. So this is a general setting. More and more problems can be accommodated, and there are situations where we really need to optimize a set rather than a function or a vector valued functions. There are many applications which are being mentioned, that is in some of the optimizations problem areas where they are being used is in duality principles, in fuzzy optimization, because in fuzzy optimization you have to talk about a range in which you have to optimize, or interval optimization, robust optimization, or even bi-level programming. You have one problem which is being solved, and there is a constraint, there's another problem. So the constraint problem, when we solve, the solution set may not be unique. You have more than one solution, and then you have to solve the main problem. So bi-level or more than one level problems can be cast in the set valued optimization setting. MPEG problems, game theory problems, and this is one of the good book on set valued optimization which appeared in 2015, which has a very good literature, theory, as well as some applications are listed. And I've taken many definitions from this book for my work. As we go ahead, we have to understand a set valued optimization and what we mean by the concepts related to that. For that, we first have the notion of a cone. This is known to most of us, many of us would be knowing, but still I would like to say what it is. If you are talking about a set K, it is said to be a cone. Whenever you have a point X multiplied by a non-negative number, that should still remain in the set X. So that is a cone. So you can see this is X, when I multiply it as 3X, so it's an unbounded set, 3X, it remains a cone. And this is also a cone because if I have a point and I completely join that point with origin and extend it, it should be completely in that set, in the positive direction. Lambda cannot be negative. So if I have a point here, extend it, it will be in the set. So this is another cone. This is a convex cone, but this is a non-convex cone, but both of them are a cone. And a cone is said to be pointed if K intersection minus K is singleton 0. There can be non-convex pointed, non-pointed cones, but here the intersection of K and minus K is singleton 0. It's in meeting at one. The common point of intersection is origin. So when I'm talking about cone, lambda equal to 0, that means X belongs to K, lambda is 0, so 0 will always be member of K. K may not be closed, may not be closed, but with the examples which I've drawn, they are all seems to be closed. Now, the cone induces ordering. How is it inducing a ordering? If K, we take it as a pointed convex cone. So three things are important. It's pointed, it's convex, and it is a cone. So what is the relation, or what is the partial ordering? What is the ordering we define? For any two members y1, y2, y1 is said to be less than equal to y2 when y2 minus y1 belongs to K. If we are in real number, there is already a natural ordering. But when you go from R to R2, we don't have an ordering. I cannot say 1 by 2 is less than or equal to the point 2 comma 1. There is no ordering in there. So to induce an ordering, we have to have a cone into picture, and that is how the ordering is defined. Y1 is less than equal to Y2. If Y2 minus Y1 belongs to the cone. This is a partial order because reflexivity happens. Y is less than equal to Y. That means Y minus Y should belong to K. So because 0 is already in K, the reflexivity is ensured. Antisymmetric property is ensured because Y1 less than Y2, Y2 less than equal to Y should imply Y1 equal to Y2. That is coming because of the pointedness. Y1 less than equal to Y2 means Y2 minus Y1 belongs to K. This means y1 minus y2 belongs to k. That is minus of y2 minus y1 belongs to k. So a belongs to k, minus a belongs to k. But k is cone. So the only this is a pointed cone. So only possibility a has to be 0. That is y1 is equal to y2. That is k is pointed gives us that it is satisfying the antisymmetric property. And the transitive properties that y1 less than y2, y2 less than y3 should imply y1 less than equal to y3. That is coming because of the convexity, because in cone is said to be convex. If A belongs to K, B belongs to K, then A plus B should belong to K. So y2 minus y1 belongs to K, y3 minus y2 belongs to K. The sum is y3 minus y1 belongs to K, so y1 is less than equal to K. So pointed convex cone induces an ordering which is partial ordering. So this will work in the setting of vector valued problems. That means when I have a y to be a function f to be a single valued, most of the cases the cone ordering is taken with the help of a pointed convex cone. But now when we are shifting from vector to a set valued, we have to actually compare two sets and not 2 points of the set y, two sets. So how is that comparison then? And can we have all these properties? That is not ensured. Reflexive, transitive still we can have, but antisymmetric, ensuring antisymmetric is a very big deal. It is not at all possible, and it is not, even if you assure somehow ensure this, that will be for a very, very special case. So what is that ordering when you're talking about the sets? Let us say K is a closed convex pointed cone in Y and it has a non-empty interior. Let us compare this relation which we had between 2 points. Now we have to have some sort of ordering between two sets, because set optimization elements are the images are sets rather than points. So there are two sets A and B which are sets in Y. We say A is less than or equal to B if and only if B is contained in A plus K. What we had here, y1 is less than equal to y2 if and only if y2 minus y1 belongs to k. So somewhat, if I take this on this side, it's y2 should belong to y1 plus k. Motivated by that, a is less than or equal to b. If b is contained in a plus k, this notion is from this was given by Kuraiwa in 2001. We can see this set A, this is the set B, and this my cone is R2 plus non-negative OR set. We can see A is less than equal to B because A plus K. So if I add the cone to every member, that means translate the cone to every point of A, this becomes A plus K. And we can see B is inside A plus K. So B is contained in A plus K. So A is less than equal to B with respect to this code. And as you can see, with respect to this, A is lying below key, some sort of lying below. So B is contained in A plus K. So A is less than equal to B. Now, what are the properties we can have for this? We can have reflexive is less than equal to A is okay because A is always contained in A plus K. Transitive is also AK, okay, because K is a cone, B is contained in A plus K, C is contained in B plus K. Because of convexity, we'll have that. But when we come to antisymmetric property, this is going to fail. Let me see if I have, yeah, this is the reflexive relation. This is transitive relation, holding, because A is less than B, B is contained in A plus K. C is also contained in B plus K. So when we substitute this B from here, you have this, and convexity of the cone ensures K plus K is contained in K. So we have C is contained in A plus K, A is less than equal to C. So we have reflexivity, we have transitivity, but antisymmetric fails. We have an example. A is less than equal to B is also less than equal to A, but A is not equal to B. If I add A plus K means K we have adding to every member, this is what we will get. Every member I add the code, again I am getting this. So A is sitting inside this set, B is sitting in that side set. So A is less than B is less than A. But we can see that the two sets are not equal. So it is not expected also that you have antisymmetric when you compare two sets. So antisymmetric fails. So what we have is this order, setless order relation is Cauchy order. Cauchy order means reflexive plus transitive, but not antisymmetric. How is the solution concept? So with all these complications, we have to have a solution concept which has to use this ordering. So those of you, if there's anybody who has done some little bit work in optimization theory, they will know how the things are coming, how it is being lifted from vector to set optimization. We say a point is an efficient solution of the problem P if whenever there is a point which is less than that in the set of set, so fx is less than equal to fx star. That means f of x star is contained in fx plus k. So we had this figure. This is my fx star. If there is something which is less than that, then naturally I will not prefer this. This will be my solution. But okay, when I look at this figure, if I have a situation that okay, f of b is less than equal to a, but also a is less than equal to b, and one of them is optimal, okay, the other also we can take it as optimal. So that is the notion. Whenever there is an x where fx is less than equal to fx star, then we can accept this x star as an optimal solution provided fx star is also less than equal to fx. In such a case, okay, we accept that this is an optimal solution. Another situation is there is no other x which is less than equal to this. So this is not going to happen. So trivially, that is an optimal solution. That x star is, there is nothing which is less than that. So x star is itself an optimal solution. So I have a couple of examples. Geometrically, I'll try to visualize and show you how the things are happening. So we denote by fs points which are the images of these points. X is there, fx is a set. So it's a family of sets. Family of sets we denote by fs, and the collection of efficient solutions as L efficient. So you can just forget about this fs because that's not going to. L efficient means the set of optimal solutions, and L mean is the images of the optimal solution. So if we have x, which is an optimal solution, which will be x star is an optimal solution, take its image, collect those sets, that will be a set. L union of fx will be L mean. So L efficient fs is collection of points in the set capital S, which is a collection of single points, x star, x1 star, x2 star. It's a collection of points in the matrix space X, whereas L min fs is the collection of sets in Y, not point, but collection of union of manius sets. So when you have sets, those ordering has to be in terms of the set relations. All these concepts are coming from the many papers of Kureva, the one of them which I have listed, the earliest paper. So we have an example to see whether what are the optimal solutions. Let's consider a function which is a set valued function defined from R to R2. So my metric space X I have taken as R and Y as R2. So we have to take a cone in R2. So we usually, I'm taking a very ordinary, most sorted after cone, which is the non-negative ortho R2 plus. The feasible set is 0 to 1. Feasible set is in the set R, so it is 0 to 1. And let me consider a set valued optimization function where the function f is given by f of, if x is 1, you can see if x is 1, this is my 1, the image of that is 0, 1 cross 1, 2. So it is x is from 0 to 1, y is from 1 to 1 to 2. So this is the image of the point 1 in the domain. Image of 1 is this set. If the points are between 0 to 1, not including 1, let us say half, then what will be the value of half? It will be the set half plus 1 to half plus 2, that is 3 by 2 to 5 by 2. So this point is 3 by 2, this is 5 by 2. And the other one, y-axis, it is half to half plus 1, that is half to 3 by 2. So this is half and this is 3 by 2. So this particular square is the image of f under half. Similarly, when we take 3 by 4, it shifts little above. And when I take x equal to 0, it is 1, 2, that is image is from x-axis 1 to 2. And at 0 to 1, y-axis, it is from 0 to 1. So this blue graph, this blue triangle, blue rectangle square is the image at x equal to 0. And when it is neither between 0 or 1, it's outside this set. Let me take it as empty set because we are not bothered what is happening outside the feasible set 0, 1. Now, what are the efficient solutions? We can see that f of half, f of 0 is lying below f of half. But f of half is not lying below f of 0. So f of half cannot be an efficient point because there is something which is lying that below it, but this is not lying below f of half. So f of half cannot be efficient. F of 3 by 4 cannot be efficient. But is f of 0 efficient? Yes, because there is nothing which is lying below it. If there is something lying, then only I have to check. But there f of x, if I take 0, there is no fx which is lying below f of 0. So okay, this is trivially satisfied. I don't even have to check it. 0 is an efficient point. What about 1? 1 is also efficient because there is nothing which is lying below it. And there is nothing lying above. If I add, if we add this, maybe a point will come over here, but it is above it, not below it. So maybe f of something 0.9 may come little above. 0.9, how much it will be? 0.921. No, even that will not come. So there is nothing lying above f of 1. There is nothing lying below f of 1. So f of 1 is also an efficient point. And the image of that will be f0 union f1, will be the decision space is 0, 1, and this is the image space where we can see that we have to compare, we have two sets and we have to sort about comparing the sets. By comparing the sets, we have got the image. Now, when we talked about scalar optimization, we said that the stability is ensured when there is a continuity notion. But when when we are considering a set valued map, the continuity notion is also changing. There are two notions. One is upper semi-continuity and then there is a lower semi-continuity. Fortunately, both those concepts are reduced to the notion of continuity for single valued map. So I can say that this notion extends the notion of continuity for the single valued map. Now, two notions are upper semi-continuity and the lower semi-continuity. F is said to be upper semi-continuous whenever we have an open set. When we have an open set containing B, then there should be a neighborhood around x star such that for every neighborhood f of x is contained in B. So like you have inverse image of open sets of a continuous function is open. So that condition is being here taken here. You have an open set, then you should have a neighborhood around which that point x star, all the members of fx should be contained in B. So this is the notion of upper semi-continuity. An example, very simple example I'm taking. We take a function where at x equal to 0, I'm not taking the boundary. The boundary is missing. But at all the points for x of 0 in the domain 0 to 1, it is the closed set. We can see it is not upper semi-continuous because if I take at 0, f of 0, we take a neighborhood f of 0 and I take an open set. I take the set V itself to be f of 0, which is an open set. F of 0 is contained in V. But I take the closed set, in the neighborhood is the closed set, and the closed set cannot be fitted inside the open set V. So when we take the set V, there is no, this is already an open set. We are just taking sometimes the set V as F0 itself. So it is not working when you have this type of scenario. To avoid this, we talk about, there is a concept called Hausdorff upper semi-continuity. In Hausdorff upper semi-continuity, we do not take sets of the form V, but something like V plus a ball around it. We cannot avoid the same set, but you have to take a little bigger set so that this can fit inside it. So that is the notion of Hausdorff upper semi-continuity. We'll define that. Hausdorff upper semi-continuous means whenever fx is contained in, fx star is of course contained in, you can see fx star is always contained in fx star plus the ball. Ball is, if we add small balls around this, slightly bigger, make it slightly bigger, as small as you want you can take, but it is open set, then this should be sitting inside this for the neighboring points. So that is the concept that fx should be sitting inside fx star plus ball of the open balls. You take the collection of open ball for every eta. So however small you take, this should happen. This is the notion of Hausdorff upper semi-continuity. And in this example, even though F is not upper semi-continuous, it is Hausdorff upper semi-continuous. So there is a little freedom to move. That is the main point in Hausdorff upper semi-continuous. Not that only you take set of this form, you have to take sets V of a particular form. So this example, F is not Hausdorff upper semi-continuous, but it is Hausdorff upper semi-continuous at x equal to 0. So what are the relation? Whenever it is upper semi-continuous, it is Hausdorff upper semi-continuous. But the converse is not true. But if f of x bar star is compact, then example which I have taken, it is not compact. If it becomes closed and bounded, it becomes compact. For finite dimensional, it's closed and compact. And this is a finite dimensional example. This is not compact, that is why the problem. Had it been compact, then Hausdorff upper semi-continuity and upper semi-continuity become equivalent. So sometimes to establish my stability results, I have to take Hausdorff upper semi-continuity and sometimes upper semi-continuity. But compactness, once we take, then we are happy because both these concepts coincide. These are all notions from the same book which I was referring to you, set valued optimization problem. There is a similar concept which is called lower semi-continuity. Lower semi-continuity means if we have an open set V such that Fx star has a non-empty intersection, then there is a neighborhood around X star for which every point of that neighborhood Fx has also a non-empty intersection with V. We have this example. This is f of 0, this set, and for other points it's simply f of 1. So this is not lower semi-continuous because if I take an open set somewhere here, this has a non-empty intersection, but all the points in the neighborhood, let me take the points on the right side of 0, 0 to 1, it is f of 1, and f of 1 may not have the intersection, has a non-empty intersection with this set because it's sitting nearer to this point which is not in the set f of 1. So there you see that the lower semi-continuity is failing. Lower semi-continuity is not lower semi-continuous at 0, but it is lower semi-continuous at all other points in the domain from except 0. Similar to that, we have Hausdorff lower semi-continuous, a slight modification. There it was fx was contained in fx star plus beta e0. Now it is fx star is containing in fx plus beta e0. This is the same notations. Here instead of the set V, we are talking about a set V which can be of the form set plus a neighborhood around it. So that gives you the notion of Hausdorff lower semi-continuity. And this example, it is Hausdorff lower semi-continuous, the one we were talking about earlier. I'll not go into the detail. It can be easily seen fx plus beta. So this my any point I take a ball around it. We can see f of 0 sits inside f1 plus that ball. So this is perfectly all right. It is Hausdorff lower semi-continuous. In upper semi-continuous, upper was implying Hausdorff. And lower semi-continuous, the other way around, Hausdorff lower semi-continuous implies lower semi-continuous, but when we have compactness, both these notions are same. So these were the concept of lower and upper semi-continuity. Both of these concepts boil down to the ordinary concept of continuity in the case of single valued map or single functions which are real valued. So this is the continuity notion. Then if you had remembered in the example which I had given earlier, there was a concept of convergence in this example. Yeah, this Sn, there is a set Sn, and this Sn was somehow converging to S as n tends to infinity. So again, when we are talking of this is very simple, but when you have to talk in terms of definition, what do you mean by a set Sn converging to S? We will have two notions to understand this. One is Painley-Kutkowski convergence and the other is Hausdorff convergence. So there are two notions of convergence of sets. For that, One is a notion of distance and excess function. Distance means we have the set A, then another set B. What is the distance of a point X from the set B? You take a point X here, then find its distance, closest distance from B, and then take the infimum. That means take any point X here in B, find the distance from X from U, and find the smallest distance. So this is the smallest distance. So dxB is this distance. And what is excess of A over B? Take the distance of every point from the set and take their supremum, maximum distance. So this, in this case, this excess is this much. That means how much is A coming out of B? How much is it exceeding outside B? How far is the set A outside B? We have to converge. We have to talk about the convergence. So ultimately, we want to make this as small as we want, that this convergence. Here A is outside B, so this is the excess. Similarly, we can have excess of B over A. That means how much is B exceeding outside A. Two concepts are there. With the help of this, the notion of Hausdorff convergence, we have a sequence of non-empty sets. We say Sn Hausdorff converges to S, provided the excess of Sn over S goes to 0. That means how much is this exceeding? As we move A, take a sequence of ANs, that distance should go to 0. That means excess of Sn over S should go to 0. Excess of S over Sn should also go to 0. This is Hausdorff convergence. When we only talk about one part, that is Esn going to S, then it is upper Hausdorff, because we are coming from outside. Sn is how much is Sn exceeding S. When this is lower, when how much is the original set S exceeding over Sn, that going to 0 is the lower part of convergence. So this is upper Hausdorff convergence and this is the lower Hausdorff convergence. Similarly, there is another concept called Painley-Kuratowski, for which there are two notions. One is limit inferior of the set and the limit superior of the set. I'll try to explain this with the help of this set. Look at this set. This is the set S. I have a sequence of sets. One is S1. S1 is this set. Then S2 is this set. And S3 happens to be the same set S1. S4 happens to be S2. And these are the sequence of sets. We want to see what is limit superior and limit inferior. Limit inferior means we have to take all the sequences. Wherever we take a sequence, it should go to it. So what are those points? If I take a point here, this in this triangle, that point is there in the triangle, this in the triangle. So the common thing which is there in the triangle, so if you are taking all the sequences which goes to converge is limit Sn. But when you talk about limit superior, is the subsequence. You need not be sequence, it can be subsequence. So in this case, if we take a subsequence coming from first set, third set, fifth set, so okay, I can get to see subsequence which goes to this. So I am able to collect these points also. And from this triangles also we can get a subsequence. LSN is this. So this is the limit superior and this is the limit inferior. And it is known that limit inferior is always contained in limit superior. And when do we have the Kuratowski convergence? When we have the other way around. That is, limit superior is also contained in limit inferior. Then we say that it is Kuratowski convergence. So in this example, we do not have the Kuratowski convergence. So the notion is, if LSN is contained in LISN, Li is always contained in LS, but if this is contained and in the set S is sitting in between, then we say that this Sn Kuratowski converges to S. The upper part of convergence is simply LSN. LSSN contained in S is the upper part and S contained in LISN is the lower part. And it is known that the Kuratowski convergence is weaker than the Hausdorff convergence. Hausdorff convergence implies Kuratowski convergence. But sometimes some of the conditions we are not able to talk about. Assumption, we have to take a stronger assumption. That means we may have to take Hausdorff convergence. So these are the two notions of convergence. So this is basically what we have summarized so far is what is the set optimization problem, what is the solution concept, and what are the two notions. One is continuity notion and the other the convergence notion. With these, I'm trying to give the results. Another notion is convexity, quasi-convexity, which we have extended to the set valued setting. Whenever fx1 is less than fx, whenever fx2 is less than fx, then f of alpha x1 plus 1 minus alpha x2 is strictly less than fx. So it is the convexity assumption. Kindly let me know when how much time I have. I'll try to
In
find.
fact, you just touched the line, but no problem, ma'am. You can go ahead for a few more minutes. No
Okay,
problem.
I'll try to wind up, not take much time. So because I'm coming to my main result. So this was the external stability result which we have done earlier. I'm not going to that. So these are my main results. So let us see how the result is coming in set valued setting. What are the assumptions we have to take? In external stability, we have to have a sequence coming from the perturbed problem, and we want to see whether that solution converges to solution of the original problem. So that is the idea we have explained. Sn is a sequence of set. F is, what are the assumptions? See, I have to take F is not only LSC, I have to also take USC. F has to be compact valued. So if I take compact valued, it can even be Hausdorff lower upper semi-continuity Hausdorff because they are equivalent. The set S has to be not only compact, it has to be convex set. So so many settings have to be put. F has to satisfy some convexity assumptions. Sn upper Hausdorff converges to S and lower Kuratowski converges to S. You take Xn, which is the optimal solution of the perturbed problem, that is Fxn belongs to L min Fx. Then, under all these assumptions, we are able to find an optimal solution of the original problem such that, and a subsequence of this, not a sequence, but a subsequence, which ultimately makes Fx and k goes to Fx. That means the image of Fxn converges to Fx in the Kuratowski sense. So this is the main result which we have obtained, and this is published in this paper is published in Optimization Journal, and this is the main contribution in terms of external stability. And to obtain the another result, which is the internal stability, I need to assume L domination property. That means if we take a set, it is either a minimum. If it is not minimum, there is something lower than that is minimum. That means every family, every member, either it is a minimal point set. If it is not, then I'll be able to find out another minimal set which is lying below that. That is a common thing which is used at many places. Using this, we'll try to extend this internal stability result to the set optimization setting. In internal stability, we start with the optimal solution of the original problem and try to see whether it can be approached by an optimal solution of the perturbed problem. So this is the main result. Sn is a sequence of non-empty sets. F is HLSC, HUSC. Here I don't require F to be compact valued, only close valued. S is a compact set. It satisfies domination property. These two are the same assumption. We start with an optimal solution of the original problem, that is Fs without the perturbation. Then we are able to find out a sequence, or in fact subsequence, of X and K, which is the optimal solutions of those problems, which converges to Fy. Unfortunately, Fy is not going to Fx, but Fy is equivalent to Fx. That is some sort of equivalence. I have not explained this, but Fy is equivalent to Fx if Fy plus K is equal to Fx plus K. This result is true. So this is the main internal stability results in our paper. Of course, we have done many other relations. I'm not putting all those things. Those of you interested can have a look into that paper. But only the main internal and externally stability in set optimization. So that is all from my side. So if there are any queries, I'll be happy to answer.
Yeah. I'm requesting some of these delegates to throw some doubts or maybe queries if at all they have.
I know this may not be the area of many other people because it's a diversified conference, people coming from various fields.
May I request Ms. Varalakshmi to raise any points for discussion? If not, okay. I have a small doubt, ma'am.
Okay.
In data envelopment analysis, DEA,
Mm-hmm.
we have a method to estimate the efficiency.
Mm-hmm.
Yeah. Whereas in your thing, we have efficient solution. The topic
Mm-hmm.
efficient solution.
Mm-hmm.
How we can see these two things together?
You talk about efficient frontiers, I suppose.
Yeah.
Yes.
Exactly.
So this is a set optimization problem. When we reduce the set optimization to single valued optimization problem, we get the same concept. This concept reduces to the notion of efficient point in the in the vector optimization problem. And if we collect all those points, you get the concept of efficient frontiers, efficient optimal solution. So it is a further step from that concept to other set optimization notion. If we
Oh,
just work it out, some calculations, it can be shown that it reduces to the same notion.
yeah. I have seen one more good opportunity in your topic because when I worked on DEA,
Mm-hmm.
we found some sort of activity to rank the companies, or maybe based on their efficiency, we can see where they are exactly, with whom they have to compete. But
Mm-hmm.
here in your presentation, I found something very good. So now we can even see how to optimize your inputs. Because
Mm-hmm.
in DEA, we have only input orientation,
Okay.
estimate the efficiency, whereas you are giving us a solution how to improve the output by optimizing input. I think that is one good thing I have seen from
Mhm.
your presentation, ma'am.
Yeah, this concept has lot of application, and many people would be doing in data envelope analysis also in the set optimization criteria. Maybe they are doing.
Especially, yeah, especially for people like Miss Monisha in Infosys, number of minimum people required to perform such kind of activity. In
Mm-hmm.
that, your optimization solution is really going to work out a lot.
Hmm.
I think,
Previously, what was happening was when you're talking about an optimizer, it was even if you have if suppose you have a cricket team and you want to select the best cricket team, the optimization concept was even if one member is good enough, we select that. But with this approach, you cannot have a team with one good member. It is the whole thing which has to be taken in totality because you're comparing two sets rather than one point of a set and another point of the set. That is the advantage of this
yeah,
approach.
yeah. I think Miss Monisha, if she's there, I think she can talk about that optimization for industry.
Yes, we deal with data a lot in every aspect, not only in the recruitment process or otherwise. A lot many complex situation we face, and definitely, I have to go more into detail to kind of clearly grasp these this particular theory which Madam just explained. How do we utilize this? Because I'm sure definitely we will be, it will be helpful for us also to, I can, what I can do, I can kind of connect with some of our technocrats who are dealing with data and see or get this paper to understand more and then explain if they can, apply this somewhere.
Mhm. Okay, I'll be more than happy to.
Thank you, madam. Yeah.
Yeah, ultimately that is the reason we want to have interaction with.
Yes, yes. Yes, yes, sure, sure.
Yeah, if no other delegate has got any points to discuss, I think we'll say thanks to ma'am.
Okay, thank, thank you. Bye bye.
And Dr. Rajsekhar sir would like to say a word.
Thank you, Lalita, for your nice lecture. Whenever Dr. Lalita is giving a talk, I am always recollecting my good mentor. So that is, motivator, Dr. M.C. Puri. So he is responsible, and the first letter after my return abroad, number Dr. M.C. Puri has given reply. You please start war as a chapter. We are all with you and we will help whatever else. And whenever he is coming for all the conferences and everything, Tirupati or other places, maybe you have blessed. Since you are staying in Tirupati and you have Balaji, all the blessings from Balaji, please do something like so. right from Lalita, when Lalita is right, the group of students of MC Puri, right in 99, she came to Tirupati, and 2008 also she came. And while I was a registrar of Gavin University, she came all the way from Delhi to Gavin University to give a talk on mathematics programming. That time the workshop, and later she also came on 2014. I'm very happy, madam, because today again I'm recollecting my guru, Professor
Yeah.
Puri, for all today. Vijay Sarkar knows that today there is MC Puri prize in war society they have awarded. So there are many people, senior people, they have received that award. I'm still recollecting the days with my guru, Professor MC Puri. So thank you, madam. Thank you.
Thanks for reminding me and his blessings.
Thank you.
Now it is time to go for the third session. I'm happy to and privileged to introduce Vijan Sarkarji.
Yes.
And the good thing is I'm just a secretary to Tirupati ORSA chapter, and
Oh,
he is the
welcome.
he's secretary to the national chapter of ORSA.
Oh, thank you very much. So it's a good. Glad to see you.
Yeah, it is my pleasure, sir. Now, I just give a brief of our Vijan Sarkar sir, and he is in charge of production engineering department in Jadavpur University, and he has got 3 decades of experience in teaching, industry, research, consultancy, and he's also published 200 papers, if I am right, and guided 27 PhDs. And he is also expert member in AICTE inspections. And apart from that, he has developed a lot of MDPs, MDP modules, Management Development Program modules, apart from regular FDPs. Then he has also handled so many projects from UGC with the help of Government of India. So apart from that, if we see, he worked as a chairman in production engineering division of Institution of Engineers. Okay, so with this brief introduction of Vijan Sarkarji, I just want to hand over the session to him. I welcome you, sir.
Thank you very much, and good morning to all the audience present here on the occasion of birth centenary celebration of VIBHUSHAN Professor C.R.RAO. We are thankful to Professor Rajshekhar Reddy for giving me the opportunity to express our deep gratitude to Professor C.R.RAO for his outstanding and astounding accomplishment in his career. I am thankful to all the committee members for providing me such a beautiful opportunity. The topic of the seminars for the consecutive 3 days, advances in operational research for optimal humanosphere. During the inaugural session, Professor VIBHUSHAN Rao explained beautifully the importance of humanosphere and operations research taken together. So really the topic of discussion is wonderful. Once again, I thank you, Professor Reddy and Professor VIBHUSHAN Rao, for explaining the importance of humanosphere in the domain of operations research. Now, my topic of discussions is innovation in optimization. Am I audible to all of you now, sir? Hello?
Yes, sir. You're audible, sir.
All right. All right. My topic of discussion for today's seminar, innovation in optimization. Basically, optimization it has got a long history. From the day of inception of the civilization, people are always trying to find out to do the job in a very optimal way, knowingly or unknowingly, in an intuitive manners, because every man has got his mind. So through his mind, his understanding, his knowledge, he or she is trying to get the job done in a very optimal way. Innovation in optimization. What is innovation? What I mean by innovation, the innovation means the novelty in the work, any work, whatever you are doing, whether we are doing in a holistic manner or the eclectic manner or exotic manner. So whole domain of whole domain of optimization is shown by this simple slide. You see the slide has got three major components. One is the lemon, and this is glass, and this is a jar. See, lemon is the resource. In our the life, daily life, social life, corporate life, worldly life, wherever we stay, we have the resource, limited resource. Now, question comes, how to utilize this resource, limited resource, in a maximal way. So whenever we have a limited resource, we must try our level best to
Excuse
maximize.
me,
So
sir.
the hello.
Sir, we are not able to see your PowerPoint presentation. Can you share that, sir?
Sure. Okay, okay. That's why I told you. Oh, no problem, no problem, no problem, no problem.
Yeah. Yes, sir.
Now it is visible.
Yes, very much visible.
Thank you very much. Thank you very much. Now the topic of discussions is innovation in optimization. Optimization is not a new word. From the day of inception of our civilization, global civilization, people are thinking how to do the job in a very optimal way, knowingly or unknowingly, because everybody has got a mind, and through the minds, he or she can do the job in a more excellent, beautiful manner and a holistic way. So the and innovation is a term which we deal with the novelty in the job we are carrying out in the family life, in the individual life, in the corporate life, or the social life, whatever way we are doing the job, but that should be in a very novelty way. The whole domain of optimization is shown by this slide. This slide, you can see the three components. One is the lemon, another is a glass, another is a jar. You see, the lemon represents the resources we have got. We have got in the world, in the we have the limited resources. Everything is limited. The time is limited, space is limited, resource, the water is resources, air is resources, everything is uh, limited. So, how to utilize in an optimal way these resources, limited resources, that is the crux of the problem. And this crux of the problem is not for the 2020. It was before the birth of Jesus Christ and before birth of civilizations. So the peoples are thinking how to make the thing in a more elegant way, in a holistic way, in an eclectic way. So the if you have a limited resource, how to maximize this limited resource. So that is why whole optimization is shown by, to my understanding, is shown by this slide. Because if you have a lemon, make a lemonade. Now, today's the content of discussions for the presentations, the three parts, major parts, symbiosis between AI and OR. Second part is the Boolean programming, and third part is the pseudo Boolean programming. A symbiosis between AI and OR, artificial intelligence. During the inaugural session, Professor M.R. Rao, our past president of Society Award Society, Operation Research Society of India, he has explained in details about the importance of artificial intelligence. There is a simple question. Question is that what is meant by intelligence? Second question, what is the natural intelligence? And the third question is what is artificial intelligence? There is a different definitions of intelligence, different dictionaries. Oxford Advanced Learner, they are giving a definition of intelligence, and also Webner Dictionary, they are also giving the definition of intelligence. But most important way of definition of intelligence is that doing ordinary work in an extraordinary way is the hallmark of intelligence. I repeat once again, doing ordinary work in an extraordinary way is the hallmark of intelligence. And what is artificial intelligence? When the machine, whether it's a computer, it's a robotic system, whether it's a industry 4.0, any system which can be made in such a way that it can see, it can recognize, it can understand, it can communicate, it can make decisions. Even the decision more than that an individual, a human being. When we talk about the human being, it is the Homo sapiens. So machines are to be built in such a way the machine should take the decisions more than an humano sphere, humano sapiens or Homo sapiens. And war, we all know primarily what is the war. But the present day crisis, how to make decisions by the machines based on the observations. So that is the symbiosis between artificial intelligence and the person research. The machine will not be biased. Human mind may be biased, but machine will not be biased. When you take a loan from the bank, so depending on the different criteria, the system, the machine will tell whether he or she will allow the bank loan or not. Similarly, accepting a lot or rejecting a lot, so machine will decide based on his knowledge base. So the thing is that this is the importance of integration or symbiosis between AI and OR. Next is the Boolean programming, and third one is the pseudo Boolean programming. Boolean programming when we talk about the Boolean programming, it is the George Boole. George Boole, we all know, the great British mathematician who developed the concept around 150 years ago. During that time, the people could not understand the importance of Boolean algebra. Now, gradually, we understand the importance of Boolean algebra, Boolean variables in our operation research level. Similarly, pseudo Boolean programming, it is a new concept. It is in India particularly, but in foreign, P.L. Hammer, who is the father of pseudo Boolean programming, he developed this idea in 1963, almost 50 years ago from today. It finds wide applications in the domain of operation research. Now, symbiosis of AI and what? Whenever we go for the AI and what, we find out that it finds the different applications like the natural processing, NLP, natural language processing. We find the robotics, how the robot can make his optimal decisions based on the facts and figure which is being given to him. So we make certain kind of the expert system also. Now, when we talk about the expert system, it has the major three components. One is the user who is a non-expert who is actually using his facts and figures, and that there is a knowledge base is there, and there is the inference engine. Knowledge base is the static knowledge base, which based on the knowledge engineer they extract the knowledge from the person who has got the vast knowledge about the particular phenomenon, particular experiments. Now, inference engine is like a traffic police. It controls the whole scenario. It takes the information, the data from the users, and it interacts with the knowledge base based on its control part and selection parts, execution parts. So the thing is that inference engine, which is the prime mover for this expert system, it based on the forward chaining or the backward chaining. So it acts with it takes the information or the data from the users and interacts with the knowledge base, and ultimately it gives back to the gives back to the users is decisions. So the expert system, whichever we are talking about, in the place of the operations research, we develop the knowledge base, and inference engine will take the information or the data from the users, and based on interacting with the knowledge base, then it will give the decisions to the users. So that is the most important point in a day nowadays, because here is no human touch is there. Human touch is there. The machine will take care of the decisions, and this decision will be absolutely right, because no blood chemistry will not be there in the system. So that is why whatever decision is coming is free from blood chemistry. Now, whole domain of AI is a symbolic logic, using of the symbolic logic. We talk about the deductive inference. There's another deduction, another inference is that inductive, but whole AI is based on the deduction. From the population, we come to the sample. Now, GBS, George Bernard Shaw, as for example, George Bernard Shaw was a bachelor. George Bernard Shaw was a bachelor. The question comes, one can deduce that GBS was unmarried. Very simple. If it is given George Bernard Shaw was a bachelor, how can we find out that GBS was unmarried? How can we make the decision? The decision is that we know that all bachelors are unmarried. Therefore, George Bernard Shaw was a bachelor, therefore George Bernard Shaw was unmarried. So, dear friends, so whole domain of artificial intelligence is based on the symbolic logic. Now, question comes: this logic is a reasoning based on certain facts and figures. Now, this reasoning is a new day. No, Alan Turing, who developed the first machine, this computer processing system in 1936, Turing, which goes by the Turing machine. Now, he developed the concept of this kind of decision making based on the symbolic logics. Then comes what is very important, whether this decision, this logic is a new days, is a 19th century, 100 years old. No, it is not 100, it is more than 2000 years old, because during the time of the Aristotle, Socrates, Plato, the logic was coming. Because I told you that decision making is the human mind. It is the human mind which makes the decisions. Because every man has got a mind, and every man is a decision maker. Every man, irrespective of the caste, creed, culture, religion, every man can make the decision because he or she has a mind. The question comes: how to make the holistic decision? Here lies the importance of interaction between AI and one. So GPS was a bachelor, so one can easily deduce that was an unmarried. Now the content for the AI work. So we shall first see logical connectives. What are the different connectives that there in the symbolic logic or in the AI? Then we modeling approach to logical inference, how to deduce the inferences. Then the linear programming, integer programming applied to logic, and logic applied to integer programming. Now logical connectives. Now you can see there are primarily the 5 logical connectives: negation, conjunction, disjunction, implication, and biconditional. Now the P and the P bar, you can see the P and the P bar. This P stands for the proposition, and negation of the P bar is your negation of the proposition P. Now question comes: what is P? What is the proposition? Proposition is a statement which has the functional values. Proposition is a statement which has the functional values. The question comes when it says that the proposition is a true, and that this is true. This is the P is the truth. It has the truth value. Then the negation of this truth will be the false. Similarly, when it is the false, it is the opposite will be the true. As for example, if we take a statement, now is it the winter season in India? Is it true or false? So if it is a true, then it will be true. Otherwise, it will be false. So that is of the negation. Now coming back to conjunction, this is the basically AND gate. In the logical AND gate, we consider the 2 propositions P and Q. So if the output will be the true only when both the inputs are the true. The P, you can see the 3 columns P, Q, and P conjoint Q in the third column. The first 2 columns, the first 2 columns talks of the input, two inputs, and the last column, the third column, is the output. So whenever the first proposition is the truth, second proposition is the false, then the output is the false. First proposition is the false, second proposition is the true, then it is false. When both the propositions are false, then the output is also false. But when both the inputs are true, then the output will be the true. Now coming back to disjunction, like the previous one, you can see the 3 columns: first column, second column, third column, and there are the 4 rows. Now the P is the one proposition and Q is another proposition. Now P is it is raining, and Q is it is shining, sun shining. Now the thing is that if it is true, and both it will be only false when both the inputs are the false. Otherwise, whether any of the propositions are true, then the output will be the true. So this is disjunction. Now coming back to the implications, again you can see the implications. The arrow sign is shown here. P and Q, and P implies to Q. Now the thing is that the first proposition P, if it's true, and the output, and the second proposition is true, then the output is true. That means if then. Implication means the if then rule. If P, then Q. Here you can see the output will be false when the Q will be false. Now coming back to the biconditional, if P then Q, and if Q then key, and then P. So this is biconditional. This is also a very important logical connectives in the case of the artificial intelligence. So in the case of the output, in the case of the biconditional connections, the output will be the truth when both the inputs will be of same category, either truth or the false. So in the case of the artificial intelligence, this logical connect is very important. And importance of this logical connect is like this: negation will be highest importance, and the lowest will be biconditional. That means negation will be given the first priority, then the conjunction, then disjunction, then implication, and biconditional. This is the way of representation of the importance of the logical connectives in AI. Now, argument forms and the truth tables. Now, in this section, we develop a purely mechanical method for testing the validity of arguments, because of the proposition, when you give the propositions, so that's based on certain arguments. If then rule containing truth functionality compound propositions. Now, the first proposition, like here in this rule, is that modus ponens. If A, then B, A, and therefore B. That means if A is the condition, then B, there is another proposition A, therefore final conclusion there it will be the B. Now modus tollens, we shall show you 3 examples. Modus tollens, if A then B, negation of B, therefore it will be A. So this can be verified through the truth table. But how this can be verified with the operation research? This is the beauty which has been developed by J.N. Hooker, H.P. Williams. They are the stalwart in the field of this AI-OR symbiosis. And the last one, hypothetical syllogism: if A then B, if B then C, therefore if A then C. A statement form which has only the true substitutions instance is said to be tautology. That means whatever input is there, output will always be true. Let us see the example that in this slide, the column number 1, 2, and column number 3. So whenever column number 1 is the true, column number 2, the first proposition is the true, and the second proposition, second column is talking the reverse of that, negation of that, the false. But output is always true. As for example, it is when you see a glass of half glass water, whether it is a glass half filled or full filled, it is always half. Whether it is half filled, it's true. It is a full half empty, true. So whatever combination, output, whatever input combination, different combination of the input, output will be the truth. So that is what is known as the tautology. Now, some common rules used in the AI in the what symbiosis: law of double negations. Law of double negations means the negation of negation is always a positive. But in our linear programming also, we see the dual of a dual is always primal. Then we use the De Morgan's law, De Morgan's first law and second law. That is very popular. AND gate will be OR gate, and OR gate will be the AND gate with the complementary, and the commutative law, associative law, distributive law, and law of contradiction. That is very important. Law of contradiction. As we are we are attending a seminar, we cannot be outside the seminar. So if we say that we are outside the seminar, so that is the law of contradiction. Now, this is the table, a function defined by a truth table. Here you can see the 4 columns, 8 row and the 4 columns. A, B, C are the input, S is the output. The question comes, how you can see the different combinations of the input A, B, C, output. Now we have the only truth value or the false value. Here you can see the row number 3, 5, 6, 7, 8. 3, 5, 6, 7, 8 gives the truth value. The question comes, how to write a statement S, clear? Considering all the truth value. Similarly, how to write a statement S, considering only the false value. So that is the importance of AI in OR systems. Now, when we say that we write a sentence, our objective of this table is to write the S in such a way so it contains all the truth values. So this is what is known as the disjunction and the conjunction. Now, the statement when you say the truth value, so you can see the ABC, A, the truth, the third row. If you see the third row, the proposition A is the truth, B is false, C is truth. So we write A, B negation, and dot C. Dot means the ANDed C. And the fifth row, if you look at the fifth row, A is a false, B is the truth, and C is the truth. A false, so A negation, B ANDed C. And coming back to sixth statement, sixth row, so A is false, B is true, and C is true. Now coming back to the eighth, the truth value, last row. So A is false, B is false, C is false. This is the disjunctive normal form. This is disjunction of the conjunction. Now the statement corresponding to rows 1 to 3, which is false, gives us to. Now if we look at the statement 1, the false, that means A is truth, B is true, and C is true. A is true, B is true, but output is false. So A ANDed B ANDed C, output is false. Now let us see the row number 2, which is also false. Row number 2, the A is true, B is true, but C is false. And row number 4, which is false. A is true, B is false, and C is false. Now, if we look at it, that this is what is known as the DNF form, disjunctive normal form. A ANDed B ANDed C, odd, A ANDed B ANDed C complementary, disjoint, A ANDed B negation, complementary, and C complementary. So we get what is known as the DNF, disjunctive normal form. Disjunction, this is a disjunction. Inside the bracket it is a conjunction, but outside it is the bracket, it is a disjunction. When you take this kind of statement, if we take by the De Morgan's law, we get what is known as the conjunctive normal form. So dear friend, always we get the disjunction and we convert to the De Morgan's law, CNF form, conjunctive normal form, which is important for our operation research. Now, modeling approach to logical inference. Now, logic expression, we talk about as I said in the earlier slides, that the proposition are either true or false. T stands for the truth and F stands for the false. For the capital letter X, when Xi is the propositions either true or the false. Now, equation number 1, if you look at it, that Z Xi ANDed X2, conjoint, Z X1 disjoint X2, equation number 2. But what is the equivalent expression for the logical expression as shown in the equation number 1 and 2? The equivalent algebraic expression when then X1 becomes 1, which corresponds to truth value, and X1 will be 0 when it becomes the false value in the logical expression. So equation number 3 and equation number 4 are coming directly from equation number 1 and 2 in the algebraic form. So whatever the logical form we shall get, we can convert it into the equivalent algebraic expressions. In fact, any propositional calculus problem, this propositional calculus, whatever we are talking about the propositional calculus in the Boolean algebra, is transformed into the 0-1 polynomial programming problem by simply applying this relationship in a recursive manner. So here is the importance of AI and OR, how to convert a logical expression into the integer programming problem. In the simplest case, the specification of X1 and X2 is true would be modeled as X1 and X2. So what is X1 in the case of the logical expression? Capital X1 and capital X2 true would be modeled as X1 and X2 will be 1. And the compound case like X1, conjoint X2, disjoint X3 would be given by, and the equivalent expression will be X1, X2 plus X3 minus X1, X2, X3 in the algebraic form. So we must consider the logical expression into the equivalent algebraic expression. A Boolean expression in the CNF conjunctive normal form is of the form D1 conjoint D2 conjoint D3 up to Dn, where each D1 is your disjoint of the proposition with different propositions. Let us take this example, equation number 6. Z is equal to x1 conjoint x2 disjoint x3 negation, conjoint x4 negation, disjoint x5 disjoint x6 negation. So it will be true. Now Z will be true if both the clauses are true. Now by the way, these x1 x2 x3, these are all individually the literals and the propositions of the literals, but when we taken together, the literals taken together, it forms the clauses. Now in this expression, there are the three clauses. First bracket, you can see first expression x1, second expression is x2 disjoint x3 negation, third is x4 disjoint x5 disjoint x6. So Z will be true if both the expressions will be the true. Well, all the clauses, three clauses, x1 will be true. That means it must be greater than or equal to 1, and x2 and the second clauses must be greater than or equal to 1, and third one also will be greater than or equal to 1. So that is why it will be Z will be true. Now we shall see, in fact, any Boolean expression can be converted into the CNF conjunctive normal form by manipulating the expression using various laws of distribution, negation, and divergence. Now, since Z is true, if and only if individual clause in the conjunction is true, the expression the expression 6, which is shown here, expression 6. Now, this expression is equivalent to x1 will be greater than the three conditions are there. So these three conditions, that x1, the first clause, second clause, the third clause, both must be true, must be greater than or equal to 1. So that is why the equation number 7, equivalent expression is shown by equation number 7, equation number 8, equation number 9. Now is the input-output analysis. When we, in this case, logical inference is known, is the input, and we make the certain processing, and integer programming is the output, and we all know how to solve an integer programming. So logical inference is the input. So we get the problem, industrial problem, in the logical form, in the natural problem in the logical form. Then we convert it into the integer programming through the processing that we have already discussed. Let us take integer programming applied to logic. Now, problem, the proof x1 is true. Now this is equation number 1. Given that different conditions, equation number 2, which is if x2, then within bracket x3 implies x4. Now this implication, if then rule, equation number 2, equation number 3, equation number 4, and equation number 5. So these are the known constant in our colloquial word language. It is the constant. Prove that x1 is true. So now we can see that the 5 variables are there. 5 Boolean variables are there. So 2 to the power 5, they can be either true or false. So 2 to the power 5 means the 32 specifications, combinations will be there. Now out of these 32 combinations, how is it possible to make this is correct or not? Now when the variable is only 5 is fine. When it becomes 10 variables, so 2 to the power 10, 1, 0, 2, 5, 2, 4. So there are so much combinations will be there, more than 1,000 combinations. How is it possible to make decisions, to verify the result from this truth table? It's very difficult. Now if you increase the number of the variables, 20 variables are there. So you can see it is more than 1 million combinations. With specification for the truth table, very difficult using the traditional truth table, in the conventional truth table. So we convert it into the integer programming. This logical problem is converted into the integer programming, which becomes very easy to solve and get the right result. And we shall also apply another method in AI, which goes by the name resolution by repetition. We shall show side by side both the integer programming and the resolution. They will give the same result, which will be verified by the truth table. Now, to the five possible specifications of the vector Boolean variables A, B, C, D, E, and this is 16 and the 16. So 32 combinations. Out of this 32 combination, how to find out the result which is given by the conditions which has been shown in the previous slide. Now, this problem which already shown is converted into the equivalent CNF form, conjunctive normal form. Verify the sorry, prove x1. Now the equation number 7, 8, 9, 10, 11, they are coming by just changing the rules, the de Morgan's first law, de Morgan's second law, and also the principle of double negations. So those rules are being used to convert a implication to the conjunctive normal forms. Now, this yields the following linear 0-1 programming. So, optimize x1 subject to this condition, constant 13, 14, 15, 16, 17, 18. These are all coming from the previous slides. Now, x1, the Boolean algebra has been converted to the equivalent, algebraic expression integer programming, and we say that x1 will be either 0 or 1. If 0 is the false or 1 is the true. Now, the same problem is solved by what is known as the resolution principles. Now, in the case of the resolution principles, what we do, resolution by repetition, it goes by the names. We try to verify. We try to verify that x1 we verify that x1 is false. X1 is false. So what we do, we assume that x1 is false. So based on that, we make it x1 is false, and we shall see whether ultimately it is contradicting or not. If it contradicts, that means our x1 is true. So the resolution principle is based on by the refutation. Whenever we give the statement, we negate it. The given statement is negative. We negate it. Then we see whether this negation gives the contradiction or not. If it gives the contradiction, that means our negation is false. So that is the reverse way of finding out the truth value. So here you can see the first equation, equation number 14, x1 minus x1 plus x5 plus x2. Then you can see here x1, you can see here you can see this x1 is positive and this x1 is the negation. So these two literals get deleted, and we get the resultant value, x2 negation and disjoint x5. So this is what is known as the first resolvent. In the case of the resolution principle, we take our objective function, we consider it as a false, so we make it negation. Then we contradict with the final statement whether it is true or false. Then first resolvent is x2 negation and x5. Similarly, in the case of the x2, then it becomes x2 negation and x2, they are deleted. This literal, we get the x5 negation. Then this x5 is the second resolvent. Now x3 and x5. Now x5 is deleted. We left out with the x3. Now x3 is deleted with the x3 negation. So we left out with the x4 with x2 negation. Now x4 negation. So x2 is there. Sorry, x2 is negated and x2 is deleted. So we get the nil. Nil means the contradiction. So what our assumption was that x1 is the false. No, it is not the false. It is the true. So the same thing we are getting to the resolution principles also. Let us see a very simple example, a mathematical problem. Now, if the example, it goes by this: if the supply of the steel remains constant and the use of the steel increases, then the price of the steel rises. Uses of steel increases the price of the steel. If an increase in the use of steel implies that the price of steel rises, then there will be a windfall for speculators. The supply of the steel remains constant. Therefore, there will be a windfall for the speculation. So the thing is that in this is a problem. Question comes. This is the industrial problem. This is the AI problem. Now, how to this AI problem can be converted into the war problem? Now, we know that the proposition, the supply of the steel remains constant. This is a proposition. The question comes, if we consider this is X1. X1 is the proposition, the supply of the steel remains constant. Now, is it true or false? Then we shall check, we will verify later on. Now, the use of steel increases. This is another proposition. Is it true or false? Price of the steel rises. True or false? An increase of the steel implies that the price of the steel rises. Then there will be a windfall for the speculators. So there will be a windfall, the boon for the speculators. This is another Boolean variable, another propositions. So you can see that the 4 propositions are there. 4 propositions. So 2 to the power 4 is the 16 combination or specification will be there. Question comes from the truth table we can determine, because the number of the variables is 4. Now, had it been the 14, so it's very difficult to solve it through the truth table, because you need to have more than 10,000 specifications from the truth table. So it becomes very easy if we solve it through the word by applying the integer programming, because the logical expression is equivalent to your algebraic expression. You convert it. If logical expression is converted to the CNF form, conjunctive normal form, then you convert it into the integer programming, and we solve with the help of the standard formula, branch bound technique, or the cutting plane algorithm, Gomadi algorithm. So these are the things which we can solve it. We have been some software. We have used the software Toda and Taha, developed by Professor Taha, Hamdi Taha. So we shall see the result will be the truth. So therefore, there will be a windfall for the speculators. Ultimately, the final result verify whether there will be a windfall for the speculators. So this is the premises, and final result, there will be the conclusion will be there will be the windfall for the speculators. So dear friends, so this is the actual problem, the industrial problem in the AI form, but how the decision will be taken by the system. So there is the question. The system will take care of. X1, let X1 be the supply of the steel remains constant. This is a variable at the true or false. X2, capital X2 can see. So it is the use of the steel increases. This is a proposition. When you talk about the business proposition, that means it is either true or false. It has the truth or false. Equivalent to when you take into the algebraic form, it will be either 1 or 0. Similarly, the price of the steel rises and export, there will be the windfall. Now the conditions. The condition is talking about the supply of steel remains constant, and the use of steel increases, implies the price of steel rises. The first conditions, implications are the second condition talking about the use of steel increases, implies the price of the steel rises. Therefore, there will be a windfall for the speculators. In the second case, if in the second case, you can see if an increase in the use of the steel implies that the price of the steel rises, then there will be a windfall then there will be a windfall for the speculators. So, and lastly, there is a supply of the steel remain constant. Therefore, you can see the horizontal line talking about the next 4, then there will be windfall for the speculators. Now you can see the 3 equations, 3 logical expressions, first, second, and the third. They are the conditions they are given, and finally the conclusion is that there will be the windfall for the speculators. Now we have the 4 variables that there. So 2 to the power 4 with the 16 specifications. Through the truth table you can verify, but it is a time consuming and laborious work also. But when you convert it into the equivalent logical expressions, and we can get the result. Let us see, and we shall see both through the AI resolution, repetition plan, and otherwise the integer programming, how this logical problem is converted to the integer programming problem. And the pioneer of this work is Professor Jane Hooker, H.P. Williams, and P.L. Hammer. So we equivalent to x1, x2, x3, 4 ABCD we have considered the Boolean algebra. Now to the 4 possible specification. So this is a truth table. From this truth table, it's very difficult to quickly find out the answer or the verification of the result. Now when you apply the law mentioned in the table 1, that is the law of negation, contradiction, Gibbon's first law, associative law, commutative law, distributive law, we convert it into the equation number, the expression 1, 2, 3. Equation 1, 2, 3, 4, and equation number 5 talks about you optimize the export. The final step is to write down equation number 1 to 5 as the following integer programming problem, and you can see that minimize export, that is the windfall, the windfall for the speculators, subject to the conditions. Different conditions are given, and the 1, 2, 3, 4 conditions are given, and x1, x2 are which was the equivalent to the our algebraic expressions. Now working with the table 2 has been obtained, and it is clear from the table that there will be windfall for the speculators. Now we apply this integer programming propositional calculus, and with the help of the TODA, we find out the objective value 1. So so this one talks about the double windfall for the speculators. There will be boon for the speculators. As a steel use of the steel increases, the price increases, so there will be the speculators will be right. Now this has also been proved by the application of the principle of resolution as shown below. So this is the we consider that is the our proposition, our conclusion is false. So this is the assumption. So what is in the case of the resolution by repetition, we always consider the negation. We negate our proposition, negate the proposition. So x4 has been negated, and ultimately we can see it's a contradictory. It proves that our proposition is absolutely right. So the resolution, and by integer programming, we verify a AI problem into the word problem. So final conclusion in this case of the AI word combination, all logical problems should be converted into the CNF form. Whether it's the DNF to the CNF form, subsequently formulated into 0-1 integer programming, it is easy to handle, and the result can be quickly obtained. In this case, that there will be a windfall for the speculators, and integer programming should matches with those obtained by the resolution. And the tool which I am not discussing here, Davis, Putnam, and Logman and Lobeland algorithm, which also supports the our propositions that AI can be converted into the word, and we can get easily the right result. Our second point is our Boolean programming in budget allocations. Basically, Boolean algebra was developed by George Boole, the English mathematician, around 150 years ago from today. During this time, he said whether the variable, whether it's conjunction, disjunction, negations, implication, or bidirectionals, is a true or false based on the truth table, and how to this truth table converted into the linear algebra. Linear programming, and we find out the wonderful result, which is very difficult in the case of the truth table. And we apply this concept in the media data and media allocation problem. Basically, in the media allocation problem, we have the cost is limited. Now, how to allocate the money to the different media, either print media, electronic media, either internet, or the newspapers, or the journals, or the internet, whatever the different medias are there, because the people are looking, the sales people are looking, the more reach we to the people, then we can influence the people to purchase our product. So the advertisement, the allocation of this allocation of the funds to the different media is very important, because their main objective is how to promote the sales, how to increase the sales volume, how to earn more revenue, how to increase the ROI, return on investment. So these are their main objectives. So based on that, they are going to find out how to find out which are the journals, which are the papers, which are the internet, which are the magazines where we can optimally utilize this allocation, the fund, so that we can reach maximum people. Because in the advertisement area, there is a slogan that if you reach the people, then you can influence the people to purchase the product. Now, we see where we can invest our money. Is a prime time television. The slot is very costly, and the spot media or the magazine. Where should we can why can apply, we can invest the money either in the magazine or the spot media or prime time television. So either this or not. So that is why it is called the booleans, the true or false. Now, why in the Boolean algebra of media data, we see why are the amounts of the data so huge? The very simple is that if we consider 20 magazines, let us take the very simple 20 magazines. So number of the logical possibilities will be 2 to the power 20. So more than 1 million. You see the different combination truth table. If we put it in the truth table, it is very difficult to find out the different combinations. So if we convert it into our linear programming problem, this Boolean algebra, this Boolean programming, then it becomes very easy to calculate the result. Now, logically,
excuse me. Yeah, we have already taken our break time of the next session also into our session.
Okay.
I request you to take just few more minutes to conclude the.
All right. Very quickly, I shall. Logical expression, logical premises converted to the algebraic form to deduce the algebraic arrangement and the correct conclusion from the premises. Now, this is very elementary things that we all know: disjoint and the conjoint, and also find out how to find out the reaches, maximum reaches is possible. Then the reaches 0.2, that is the 0.2 proportion of the total number of adults who are reading a particular magazine. So complementary of that, 0.8 who are not reading. So this is the way by which you can very simply find it out. And this expression talks about which are the people who are reading the magazine A, not reading B, not reading A, reading B, reading both A and B, reading not A and B. So this matrix talks about the magazine A, the people that are reading or not reading, magazine B, reading or not reading. So this is the simple data we can collect from by the survey. But how to find out the maximum reach to the people? This is only 2 magazines, so very easy to calculate. But suppose there is 5 magazines, how to find it out? So very difficult to do. So that is why Boolean programming helps us in this regard. So I'm talking about the problems. So solution is through the Boolean programming. This is an example that there are 5 magazines are there. Now this talks about what is the reaches that people are not reading, not A, not magazine A, but B and C, but not D and E. How to find it out? Very difficult. But in the Boolean programming is easy to find it out. I am skipping this one, and ultimately I am coming to this point. This linear programming, this problem is converted to the linear programming. We say that B, D, and G, the people are reading journal B, not reading D, not G. So we write D. So this is the way by which we can make the nomenclature for our understanding, and we find out from this mapping, the Venn diagram, the 3 journals B, D, G, and correspondingly we find out their expressions. So small d talks about the people. This is a percentage of the people who are reading only journal D. Only journal D. When you see the G, that is reading journal G, not reading B and D. So this is the way for formulation of our problem, and ultimately what we get, minimize these reaches, and also if at the same time subject to the conditions, and at the same time we also go to this is a decision matrix that we all know, and there are 7 variables, each variable is greater than, and this is the expression for the minimizing our reaches for the different conditions which are obtained from the survey, and we get the result. Similarly, we get the maximize the reach, and then we take the harmonic mean, and we find out what is the 0.6 is the proportion of the people who are reading both all the three journals. So here we can apply, invest our money for the three journals to get the maximum benefit. Now, pseudo-Boolean programming is another very important area, which has been developed by Richard Bellman in the 1963 with the help of the Boolean algebra. Basically, this is dynamic programming in Boolean algebra. Very quickly, I shall take 2-3 minutes how to integer programming is the input and reduced to the pseudo-Boolean programming, equivalent to the pseudo-Boolean programming. Now, this is the Gomadhi algorithm, Gomadhi problem, which has been shown here to maximize this. Now, this is the input, is the integer programming. This is converted to the, I'm going directly to your pseudo-Boolean programming. In the case of the pseudo-Boolean programming, we consider a binary development. In the intermediate, we see that x1 is less than or equal to 3 in the equation number 10, and x2 is less than or equal to 2, and x is less than or equal to 13. Now, this is the processing part which has been done by Richard Bellman. He said that when I say that the 3, so it is the maximum value is the 3. So it is 2 to the power 0, 2 to the power 1, because 2 to the power 2 is the 4, so we cannot go 4. So 2 to the power 0, 2 to the power 1. Similarly, for equation number 11, you can see the 2. So 2 to the power 0, 2 to the power 1. And equation number 12, where the maximum value is 13, so it's 2 to the power 0, 2 to the power 0 is 1, 2 to the power 1 is the 2, 2 to the power 2 is the 4, 2 to the power 3 is 8, but 2 to the power 4 is a 16, which exceeds. So we shall stop at 2 to the power 3. So these all the 13, 14, 15, these three equations are derived from the previous equations, directly, and we find out this, maximize this, and very easily we got the result, and ultimately the result is 19. And this is the last part, the minimization problem in automata theory, how pseudo-Boolean programming helps for converting the automata theory, the maximum number of the expression into minimal number. So this is the minimal disjunction from the Boolean functions. We convert it into the which is known as the prime implicance by the use of the Quine-Maclais theorem, and we find out from the 11 character, 12, 18 character letters, we get the 12 characters prime implicance, and we develop the Boolean matrix. In the case of the Boolean matrix, you see the row are nothing but the clauses, and the columns are nothing but the implicant. And you can see the 1 0 means that when the first implicant is present in the first clauses, it becomes 1. If not, then 0. So based on that, this Boolean matrix is developed, and we find out the you can see the prime implicant maximum variables is the 2. So based on that, we minimize our objective function. Objective function, the variables is the yj is the Boolean vectors. So to minimize the 2y1, 2y2, so equation number 2 has developed, and similarly 3, 4, 5, equation number 3, 4, 5, 6, 7, 8 developed from the Boolean table, and we get the result, wonderful result. So we get the two minimal junctions. So ultimately, we have the input-output analysis, we have the 18 letters in the automata theory, and through the process in pseudo-Boolean programming, we are getting the 6 letters output. And this is the step followed: find out the given DNF, disjunctive normal form, find the prime implicant, establish the Boolean matrix, find out the decision variable, write the objective function, write the constant equations, solve the linear programming problem, find the result and the final decision. Such problem arises in particular in the field of artificial intelligence and design of expert system. Let us be not unstoppable. The best is yet to come. Stay hungry, stay foolish. Thank you.
Yeah, thank you very much, sir, for that detailed things on war AI. All these days we know only war SI. But now we got the term called war AI. Okay, thank you very much, sir. Now already we have overshot the time. We have occupied the break time as well as 10 minutes of the next session. So now it is my privilege to hand over the session to the next chairperson, Professor Anand Charigaru. Thank you. Now I request Swaran to introduce our professor.
Thank you, Bidhan Sarkar. Thank you.
Once again, good morning to all. So our next session having two speakers. One is Professor Irfan Ali from Aligarh Muslim University, Professor S. Dharmaraj from Department of Mathematics, IIT Delhi. So the chairperson will be Professor Anand Rajachari. So I'm happy to introduce chairperson Professor Anand Rajachari. Sir is from founder professor of Department of OR and SQC in Rajasthan University, Kurnool. Sir has his education totally from SV University, Tirupati, and having 36 years of teaching and research experience, guided more than 15 PhD. Sir has served in various positions in Rajasthan University as registrar, Rajasthan University, Kurnool, academic senate member, special officer, PG lecturer, HOD, DOS. He has been served with multiple positions. He is having multiple maximum awards here. I am looking out a few here. He has secured university level rank in UG and PG and obtained the fellowship. He awarded with an Science and Engineering Research Council fellowship by DST, research area of reliability engineering. He got the award of Man of the Year for 2003 and the American Medal of Honor by American Biological Institute USA. He is the best. He got the best teacher award from the government of Andhra Pradesh. He is emeritus fellowship awarded by the CC. So, sir is active in referee and also published more than 50 research papers in various reputed industries. I'm very happy to having you here, sir. Please take out the session. Thank you, sir.
Thank you.
Good morning, sir. Dr. Irfan Ali.
We'll start the session. Now I welcome.
Yes, Anand, please carry on. Time is up. Always note us now.
Yeah, second. No, I'm just starting here. So we'll have discussion later on. Okay,
always request you please start make any conversation. Now, Anand, please introduce the speaker.
Thank you, Professor Rajasekar Reddy. So I welcome all the delegates to the second session, which is supposed to be started at 11:30. So about 5 minutes later, anyway, we are with the session right now. So I thank the professor and the management for giving me the opportunity to be there in the second session. Now I'll start. I think the present speaker is going to be Dr. Irfan Ali. He is present.
Yes, sir. Yes, sir. Yes, sir.
Yeah, sir. Then I'll go ahead with the proceedings of the second session. I welcome and I introduce to the audience, the delegates, the invited talk. Now we will move to the session of the Dr. Irfan Ali. I introduce Dr. Irfan Ali. Dr. Irfan Ali is currently working at the Department of Statistics and Operations Research, Aligarh Muslim University. He did his graduation, post-graduation, the Master of Philosophy and doctorate from the Aligarh Muslim University. He was awarded the UGCPSR scholarship during the PhD program. His research interests are transportation problems, busy optimization, applied statistics, survey sampling, supply chain network management, mathematical programming, multi-objective optimization, and he has supervised a few of MSc projects, MPhils, and awarded some PhDs in operations research. He has completed a research project, University Grants Commission Startup Grant Project, UGC New Delhi, India. He has published more than 75 research papers in reputed journals and served as a reviewer for several journals also. He is currently editing 2 books to be published by the Taylor Finance and Expenditure Nature. He is life member of the various professional bodies, Operations Research Society of India, Indian Society for Probability and Statistics, Indian Mathematical Society, and Indian Science Science Association. He is the associate editor of Aligarh Journal Statistics, AJS. Now with this, a few remarks in the introduction of Dr. Ali, I now move on to invite him to present his talk, introducing the talk that he has mentioned in this.
Thank you very much, sir. Thank you very much for nice introduction. Can I start now?
Yes, you go ahead.
Is I audible?
Yes, it is.
And my PPT is everybody have seen? Seeing?
Yeah.
Okay.
Yes.
So can I start? Can I start?
Yes.
Sir, first I would like to express my profound thanks to Professor P.R.RAO for giving me this opportunity to share my research views to eminent researcher of operation research. And very good morning to chairperson and all the participants of this session. My invited talk is on Sustainable Development Goals for India Agenda 2030. I am Dr. Irfan Ali and I am from Department of Statistics and Operation Research. First, I would like to introduce mathematical optimization. As we all know, this subject matter is capable of modeling and abstracting real-life situations into a mathematical formulation and solve it for an insight understanding. It helps in facilitating the decision-making process. The standard form of mathematical optimization is shown here. This is the standard form of optimization problem in which we optimize the objective function subject to a set of feasible solutions. The mathematical optimization comprises objective function, goal of decision maker, the constraint or limitation about goal, the decision variable upon which the decision maker decides his own managerial policy. So X star be an optimal solution if it optimize objective function and also satisfy the constraints. The standard form of optimization is shown here, in which we optimize the objective function subject to some set of equality constraint or inequality, less than inequality constraint or greater than inequality constraint. Optimal value, if the optimal value is infinite, Yes, sir.
Sir, you can use a slideshow, sir. In the YouTube, it will be somewhat maximized. You can click on the slideshow menu, the top.
Maximize.
Yes, sir. Yeah, that one, sir.
Yes, it is now. It is seen to everyone.
Yes, sir. Now it is okay, sir.
It's okay. Okay. Thank you very much, sir, for your kind suggestion. If the objective function value is infinite, it means the problem has a feasible solution and then decision variable not satisfy any constraint. And if it is infinite, then minus infinite, then the problem has unbounded solution. Multi-objective optimization. In introduction of a multi-objective optimization, basically in most of the real-life situation, decision making are made often in multiple phases. A situation whereby more than one goal exists and all need to be satisfied in some sense. Many mathematical optimization techniques are available to address such a condition. For our SDG modeling, we discuss three prominent optimization techniques: goal programming with satisfaction, and fuzzy goal programming. So first, I discuss goal programming. In goal programming, basically, we have multiple objective function and the FKX, where P goes to 1 to capital P, and their respective goal values ZP. Okay, so we just want to minimize individual objective function value deviation from its goal value subject to a set of constraints. The standard form of goal programming is defined in equation 2, where we minimize the over and under achievement goals, and the objective function become an additional constraint with its divisional variables equal to its goal value. So our main aim that we minimize the deviations from the goal values. So this is the procedure to how we convert a multi-objective optimization problem into a single objective optimization problem using this goal programming process. Goal programming problem with satisfaction function. Basically, in this goal programming with satisfaction function, we maximize our satisfaction function value subject to the set of constant and additional objective goal values objective function with its goal value with the divisional variables. Here Wi the weights expressing model objective relative importance, and f del I is the satisfaction function associated with these divisional variables, and E is the solution space visible for the decision maker, decision variable. So this is the object, the piecewise. For the sake of simplicity, we have considered a piecewise satisfaction function. This is defined here, and where alpha is the scaling parameters. So basically, the overall idea of this model is incorporate the decision maker preferences. The function can assume values between 0 and 1. If the function takes the value 1, that means the decision maker is satisfied completely. Otherwise, if the value between 0 and 1, the decision maker will be satisfied partially with his solution. And satisfaction function lies between the intervals 0 to 1. You can see in the figure, the satisfaction function value is minimum is 0 and the maximum is 1 here. Okay, and this is the del I values. So looking at the nature of the problem, of our particular problem, SDG problem, we consider the piecewise linear satisfaction function. So in the figure you can see here the reason 0 to alpha ID is the indifference satisfaction threshold, okay, where the deviations del I lies within the interval 0 to alpha ID, and within the interval 0 to alpha ID, evidence that the DM will be totally satisfied. Means here the function has the maximum value 1 in this interval, and the near satisfaction threshold alpha I naught, alpha and I naught. This is the near satisfaction threshold. The divisional del I lies within the interval alpha I0 and alpha I min. Okay, and this is the indication that decision maker will be dissatisfied. However, the solution is not rejected. The veto satisfaction threshold alpha I mu, this is here. This is a non-acceptance zone, alpha I mu. A region where the deviations del I lies outside the interval 0 alpha I mu, means beyond this interval, this. Okay. Therefore, any solution leading to deviation exceeding this threshold alpha I mu are rejected. In other words, the decision maker will not accept such solution. And you can see the second figure in which the decision function value, satisfaction value is between 0 to 1, and del I value is 0 to 9, 1 to 9. Here 1 to 3 is the acceptable solution range, and 3 to 6 is the partially accepted solution range, and beyond this 6 up to 9 and above is not acceptable solution range. In fuzzy goal programming, basically this is the another procedure to convert multi-objective optimization problem into a single objective optimization problem by using the membership function. And membership function basically constructed, we have solved the problem individually and get the individual optimal solution, which called ideal solution. Then based on this ideal or best optimal solution, we prepare a payoff matrix. We constructed a payoff matrix, and from the payoff matrix we identify the goal value and the lower value and upper values of the objective function, of respective objective function. So if our objective is maximization type, then the membership function is defined likewise. This is if the function value, objective function value, is greater than its goal value, that means we are greater than or equal to goal value, then perfectly we achieving our goal. This is then the membership function is value 1. And if it is in between lower value and goal value, then the function is defined by this expression. And if the function value is less than lower value, then it is completely unacceptable solution, and it is unsatisfactory solution at this stage. So basically, membership function maximum value is 1 and minimum value is 0. So this is a probabilistic space for this membership function where we have defined a function value, membership function value. Okay, so the next is when we have objective function minimizing type, then the membership function is defined likewise. If the function value, objective function value is less than the lower value, then the value is 1. That means we are attaining minimum value of the function if we have the objective function minimum type. And if the value is lying between the lower value and its upper value, then function value is this. And if the function value is greater than the upper limit, then the membership function value is 0. Okay, and if we have both type of maximum or minimum type objective function, then we combine both membership function, which I have discussed earlier. So based on this, we have converted the multi-objective optimization problem as a single objective optimization problem, in which our main aim to maximize these membership function subject to a set of constraints. Now the main topic is SDGs. So first I would like to introduce SDGs, Sustainable Development Goals. Basically, the UN Sustainable Development Goals agendas 2030 is to meet the needs of the present generation without sacrificing the ability of future generation to meet their own needs. That is to say, the future generation should not suffer from our present action and inaction. SD necessary for meeting the social goal while sustaining the natural resources upon which the economics and society depends. The pillar of sustainable development are social development, environment development, and economic development. In order to achieve sustainable development, there needs to be a trade-off between all the three objectives. That is economic, social, and ecological. So what things to be sustained? Nature means earth, biodiversity, ecosystem. These to be sustained. Life support also to be sustained. Ecosystem, service, resources, environment. Community, culture, group, places. These three components to be sustained. And what is to be developed? People, child survival, life, education, equality, equal opportunities, economy, society. These three components to be developed. So in 2000, United Nations proposed Millennium Development Goals, and these goals were 8, and these goals these goals, 8 goals, to be achieved by the year 2015. These goals were like to cover the poverty and hunger, and primary education, and to promote gender equality, empowerment of women, child mortality rate to be reduced, and HIV and other disease to be controlled, and to ensure environmental sustainability, and to develop global partnership for the development. So this is table provided to how the SDG is more advanced in respect of MDGs. Basically, MDGs adopted in 2002-2015, while SDGs adopted in 2015 and will be end in 2030. MDGs only focusing developing countries, while such SDGs applies to universally, means all countries will want to achieve these as SDGs goals. And Millennium Development Goals only have 8 goals, 18 targets with 48 indicators, while Sustainable Development Goals has 17 goals and 169 targets with 230 indicators. It is very vast in respect of MDGs goals, and this is universally applied, means every country bound to achieve these goals by the year 2030. Most of the countries are. So SDGs, a set of 17 goals for the world's future, 2030, backed up by 169 detailed targets, negotiated over a 2-year period at the United Nations, agreed to be nearly all the world's nations on 25 September 2015. So today's sustainable development is everybody concerned, for developing as well as for developed countries. To tackle the problem of sustainable development, the UN General Assembly on September 2015 formally adopted a set of 17 sustainable development goals. The main target of the UN is to achieve these goals in every sector from the year 2016 to 30. The objective was to produce a set of universally applicable goals that balance the three dimensions of sustainable development. What that three dimensions? Environmental, social, and economic. India, along with other countries, signed the declaration on the 2030 Agenda for SD, Sustainable Development Goals, comprising of 17 SDGs at the SD Summit of UN in September 2015. So the SDGs are means no poverty, zero hunger, good health, well-being for people, quality education, gender equality. So this is the unfinished business of MDGs. SDG goals 1 to 5. These goals are same as MDGs goals. So this is the repeated goals in SDGs. These are the MDGs goals, which repeated in SDGs goal 1 to 5. The next slot is clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduce inequalities, sustainable cities and communities. So these are the new areas which covers in SDGs goals 6 to 11. These goals are new, which were not considered in Millennium Development Goals. Responsible consumption and production, climate action, life below water, life on land. These goals related to green agenda in SDGs and covered by from goals 12 to 15 to foster the environmental activities globally. Peace, justice, and strong institution. These are also the SDG goals, and these goals comes under the governance and peace. SDG 16 goals. This is the goal, SDG Sustainable Development Goal 16. And partnership for sustainable development goals is the last goal of SDGs. So SDGs, basically in short, we can say 5 Ps: people, plant, and other things. Okay. These are the some summary of the sustainable development goals. And due to lack of time, I am not going to discuss these goals. A brief overview I have given earlier slides. I can skip. Now the others, this is important. It is an overview on sustainable development goals of India. So basically, India covers 6.4% of the world land area and 17% of the world, but nearly a quarter of its population lives without regular or reliable access to electricity. India's per capita GDP is around 1,408 per annum, which is considered to be very low among developing countries. Around 30% of the population in India live in poverty. About 1.7 million people are homeless, and 4.9% of the population, those is 15 years and above, are unemployed. The per capita electricity consumption stands low at 917 kilowatt hour, which is barely 1/3 of world's average consumption. According to the INDC report of UNFCCC submitted by India in 2015, India will aims to improve its GDP by 33 to 35% until 2030 with respect to the 2005 levels, and also tries to increase the share of non-fossil fuel based electricity production to 40% until then. The financial requirement for India to meet its cost for food security is around 46 lakhs crore from 2015 to 24. India will require around 55 lakhs crore till 2030 to achieve healthy lives and promote well-being for all at all ages. In order to achieve quality education and promote lifelong learning opportunities, the total financial requirement for India is of the order of 142 lakhs crores. For access to and availability of water and sanitation for all, India is estimated to require sum of 13 lakhs crore till 2030. Infrastructure development has always been on the top of the agenda for India, for which a financial requirement of 119 lakhs crore will require. For making cities inclusive, safe, resilient and sustainable, India will require a sum of 131 lakh crores. This includes housing for all, development and planning of cities, efficient transport system, public spaces and other components of urban infrastructure cost. India requires a sum of 89 lakhs crore to ensure gender equality by 2030. The cumulative cost of low carbon strategies have been estimated to be around 62.5 lakhs crore in between the year 2011 and 2030. For the study purpose, we have partitioned India into 5 zones. North zone indicated by yellow, East zone indicated by red color, and West zone indicated by blue, and South green, and Northeast purple color. Northern zone basically consists 7 states and 2 union territories: Haryana, Himachal Pradesh, Jammu and Kashmir, Punjab, Rajasthan, Uttar Pradesh, Uttarakhand, Chandigarh and Delhi, where Chandigarh and Delhi are the union territories. So percentage share of land in country total land area, Haryana has 1.34%. So largest percentage share of land is Rajasthan. Rajasthan has largest percentage share of in area wise. And population, the largest population state is Uttar Pradesh. And if you see the employment, so Rajasthan has a much employed state in respect of the other state. It has 49%. It is highest. And GDP contribution, Uttar Pradesh contribute more in GDP in respect of the other state. And per capita electricity consumption, so here the highest consumption consumed by the Delhi. So per capita electricity consumption state is highest is Delhi, and the lowest is Uttar Pradesh. So this table has been prepared by using simple statistics, basic statistics. We have collected this data from censuses and other related source of secondary data. There are all information available on the government websites, and some of the information have been taken from the census, which has been conducted in 2011 in India. This is also the other region is Western region, and this region consists 5 states and 2 union territories: Gujarat, Madhya Pradesh, Chhattisgarh, Maharashtra, Goa, Daman, Diu, and Dadar and Nagar Haveli. So the percentage of area wise of which state covers how much percentage of area in nation, in total area of nation, and population also, employment, GDP. So the study has been carried out by using simple statistics and summarized in form of tabular, so anybody can get the idea in very short time. This is southern region. Southern region contain state Andhra Pradesh, Karnataka, Kerala, Tamil Nadu, Lakshadweep, Puducherry. Eastern region consists West Bengal, Odisha, Sikkim, and the related information summarizes in table. You can see the nation share, population, state population, employment, how much employment in which state, and GDP contribution by the states and per capita electricity consumption by correspond to each state has been given in the last column. This is northern eastern region. So now the technique we discussed are to be used in optimization modeling of India SDG. So broadly, there are three major sectors of economy, namely the primary sector, which comprises of agriculture and mining subsectors. The secondary sectors is made up of manufacturing subsectors, and tertiary sector comprises of all service sectors, 4 to 9. In India, the three sectors are subdivided into 9 subsectors contributing to the economy, and GHG emission, per capita electricity consumption also collected in respect of these sectors. And these subsectors serve as our decision variables in which we determine the required number of optimal employment allocation for attaining the SDGs 2030. So basically here X1 to X9 is the decision variables, which is showing that how much employment to be generated in these sectors, so we can achieve our SDG goal. So first we discuss the GDP and GHG emission and electricity consumption and number of employment. So for a measurement of sustainable development, we focus on GDP growth, electricity consumption, GHG emission and employment across different economics activities. So the current growth rate is basically I want to report one thing here. The data in this table is from the year 2010 to 15 censuses, and the current scenario may change due to COVID-19. As you know, everybody affected by COVID-19. So basically, this is not the up to date data. It is the old data. I have worked on the data which I have taken in between the year 2010 to 15. Okay. The table 2 basically is a sectorial contribution of selected sector to the GDP of India, electricity consumption, GHG emission and employment, which is summarized here. Means agriculture, forestry and fishing, how much this sector contribute in GDP. This is the second column, and electricity consumption by this sector, and GHG emission by this section is by this sector is given here, and how many people engaged currently in these sectors is given in the last column of this table. Similarly, manufacturing, the GDP contribution through manufacturing sector, and electricity consumption by the manufacturing sectors, and GHG emission by the manufacturing sectors, and number of how many people engaged in these sectors are given in the last column of this table. So all information I have summarized this in the tabular form, and 1 to 9. Okay, and these are the objectives of our objective: GDP, electricity consumption, GHG emission, number of employment. That means we want to maximize the GDP, we want to maximize electricity consumption, we may want to minimize GHG emissions, and we want to maximize number of employment opportunities in India, basically. Maximization of electricity consumption in the sense that if the electricity consumption maximized, it means there is a need of development of industries, more industries. So this is a goal related to GDP, in which this is a per capita GDP contribution by J sectors, and XJ, how many pupils to be engaged in these sectors, so that we easily achieve our goal, SDG goal, by the year 2030. And this is the SDG goal of related to GDP has been estimated by using some statistical application. But similarly, GHG emission, we want to minimize the GHG emissions, and this is the per capita GHG emission through JH sectors, and XJ is the decision variables, that how many people to be engaged in each sector. So our GHG emission will minimized, and we estimate the GHG emission goal using the simple basic statistics. The other goal is related to electricity, and as the definition of this objective function is same as we have defined in earlier slides, and this is the employment. We just want to maximize the number of employment opportunity so we can achieve our sustainable development goals. So finally, we apply fuzzy goal programming approach. So first we have solved the problem as single objective, and then we identify the ideal solutions, and based on the ideal solution we constructed a payoff matrix, and from the constructed payoff matrix we identify the lower value and goal value, okay, and upper value of the objective function. So these membership function is defined will be the constant, additional constant subject to the set of constant of employment. So basically goal value 1, 3 and 4 are related to GDP, electricity consumption and employment, which we want to maximize. So we will use here membership function of maximization type. Okay, so these goals are to be maximized in order to realize the dream of India by 2030. While goal 2 is related to GHG emission, this goal must be minimized so that the environmental issues will remain safe. Okay, no environmental issues means environment will safe. So this is the final model. So multi-objective optimization model transformed into single objective optimization model by using membership function, and our main aim to maximize the membership function. And this membership function value will lie in between 0 to 1. If the membership function correspond to any goal is 0, that means we are not achieving this goal. And if the membership function value is equal to 1, that means we perfectly achieving the goal. And if the value is in between 0 to 1, it is meaning that we are partially achieving our SDG goals subject to that particular objective function. So the problem finally solved using the data which I have already discussed in previous slides, and the goal values, and all the values have been put in this and then solved it, and we have received results. So what the results suggested us that the achievement of the goal set for GDP growth by the year 2030 is not possible without some extraordinary efforts towards GDP growth. Also, this model predicts employment both only in the community, social and personal service, which suggests that to strengthen the GDP and increase in the employment opportunities in various other sectors is also required. This is understood by the value of which is 0.07. It is very close to 0, means we need extraordinary efforts to achieve the goals related to this particular objective function. And this is related to employment, so we are very lacking in employment. However, this value is needed to be equal to 1 to achieve this particular goal by the year 2030. The goal of electricity consumption can be considered achievable as the value of a membership function is 0.9. Thus, the model suggests that the goal related to electricity consumption can be achieved, but some small efforts and policy measures towards the clean and renewable sources of energy are required. The value of 0.94, it is related to GHG emissions, so which is quite high but not unity. Thus, the model suggests that the current policies can almost attain the goal of reduction of CO2 and other GHG emissions, but there is some need of some minor additional improvements are required to attain this goal perfectly. by the year 2030. So if the problem, this problem we have solved with 9 sectors, but if we solve the problem with only 3 sectors, means we compress the problem into primary, secondary and tertiary. Means we just consider allocation in how much allocation of employment in primary sector, how much allocation in the secondary sectors, how much allocation of manpower in tertiary sectors, so we can easily achieve our SDG goals. For this purpose, we use goal programming model with satisfaction function, and we reduce our problem into 9 decision variable to 3 decision variables, in which we only allocate that how much number of men person to be employed in primary, secondary and tertiary. Okay. So here only we consider 3 decision variables: primary, secondary, and tertiary. The allocation of personnel in these sectors has been determined, and the model suggests the optimal number of employment in 1,000 in primary, secondary, tertiary are as follows. The model simply solved using the Lingo software. So based on this study, we can conclude that an increase in the number of employees is necessary for improving the GDP growth of India. More efforts or viable policies need to be carefully considered in planning towards achieving SDG Agenda 2030. India should take some moves towards renewable technologies such as solar power and wind energy that holds vast potential for achieving sustainability related goals. These renewable energy sources can also help in achieving the goal of GHG emission as well as electricity consumption by the year 2030. So anybody can extend this research in light of probabilistic environment, because we have discussed this model with certain environment, but this model can be extended for some probabilistic uncertainty existing in the goals as well input information, since there are many real situations where the information cannot be available with certainty. For instance, now due to COVID-19, all the economic sectors have been affected badly. So the SDGs model can be again formulated by considering such uncertainties in input information and goals also. Moreover, some attribute-based multi-criteria techniques such as AHP, TOPSIS, and many other related techniques can be used to rank the most important goals. So the policymaker can take care of all priorities-based goals. So basically, this talk based on my published research articles, which is listed here, and I can also showing it my published research article. This is the first research article published in Applied Economics Letters. So if anybody interested, he or she can go these articles and explore this research topic in many dimensions. This is published in Economics Letters. My talk based on this article, and the other article published is in Journal of Sustainability, and you can see here. So the detail of this talk you can find in these published articles, in which I have discussed so many things in detail. And this is an article published again in the Environment, Development and Sustainability, and we have explored some more things in this published articles. So these articles are published in journals, and you can go through these articles if you are interested, and you can explore this area in many dimensions. This is another published article. It is not context of India, it is context of Nigeria, and I have done this paper with my student and Professor Akhil Amin Saab. It is published in journal. So thank you very much. And if there is any kind of question anybody have, you can ask. Thank you very much, sir.
Dolly, you have any questions? Kindly wait for some time so that because we have time now, because you have concluded within 45 minutes as given as a constraint to you. That's good.
So basically, the last invited talk was finished at 12, I think 11:45.
Yeah, correct.
So, yes.
Correct. That's what I said. About 45 minutes you have taken rightly. And there is no that you can.
Yes. Thank you very much.
I'm thankful to you because you have done it rightly at the right time.
Yes. So I minimize my talk. I did not explain so many things, which is I just go through very quickly on my talk.
That's a good thing because the other delegates also can make use of that. Because you have put some papers and all of interest on sustainable development.
Yes, sir. There are so many opportunities to extend this area. There are so many.
Yeah,
anybody can extend this area.
Yeah,
there are a lot of
the COVID effects and all. So these things will definitely go in where the decisions and will change, the inferences will change.
Yes. Because
how to achieve.
Yes, because I have did this research post COVID-19, but anybody can do the same research after COVID-19.
Yeah.
Okay. Because every sector has badly affected.
Yeah, true. And, yeah.
So thank you very much. Those attend my session, and if there is any query and if there is any suggestion, I really welcome those suggestions.
Yeah. Thank you, Ali.
Okay, thank you very much, sir.
We'll move to the next part of the proceedings of the session. May I request Professor Rasik Reddy to tell us whether the second invited talk is there or not? Dharmaraj is there?
Yes, sir, I am here.
Dharmaraj, sorry. Okay. So I'll move on to the second invited talk by Professor S. Dharmaraj, IIT, Mathematics, Department of Mathematics, IIT Delhi. A brief introduction. I'll briefly introduce. I introduce Professor Dharmaraj to deliver first invited talk in the next invited talk of this session. Dharmaraj had a doctorate degree in mathematics from the Indian Institute of Technology, Madras, in 1999, and he is working presently in the Department of Mathematics, IIT Delhi, since 2003. He was appointed as a Jaswinder and Arvinder Chadda Jayar Professor for teaching and research in the area of operations research from May 2010 till July 2015. Also, he was appointed as a professor, Department of Mathematics and Joint Faculty of Bharati School of Telecommunication Technology and Management from June 2013. He was appointed as an Institute Chair Professor in July 2019. He currently head Department of Mathematics since Department to September 2020. He is a visiting faculty at Duke University, United States of America, Emory University, USA, University of Calgary, Canada, University of Los Angeles, USA, and National University of Columbia, University of Verona, Italy, and Sankuyan University, South Korea. His research interests include viewing theory, stochastic modeling, performance and analysis of computer and communication systems, and financial mathematics. He has published over 45 papers in refereed international journals and over 25 papers in refereed international conferences. He is an associate editor of International Journal of Communication System and an associate editor of such. He has co-authored 3 books: Introduction to Probability and Stochastic Process with Applications, published John Wiley,
New Jersey in 2012. Again, Asian edition, New Delhi, January 2016. And the second book, Financial Mathematics and Introduction in Narosa, published 2012. One more book, Introduction to Statistical Methods, Design of Experiments and Statistical Quality Control in Springer, Asian edition, September 2018. Now, I move on, and then he now delivers, he invited Dr. Marco regenerative credit rating models. Now, over to Professor Damaras to deliver a picture.
Thank you, Professor. Thank you, Professor, for your nice introduction.
Thank you. Quite well.
And I'm happy to be giving a little talk. So I'm getting some little noise. So if others can put the mute, then it will be easy for.
Yeah. Please, if anybody there can be unmute. Mute.
Yes, still I'm getting a little noise.
Kindly see the participants or delegates to mute it so that there will not be noise for presentation. I request others to go on and see and verify, please.
Yes. I think Professor Ifran Ali has to close his presenting mode. Yeah, still it shows that.
Sir, Irfan Ali, sir, kindly stop presenting, sir.
Yeah. Dr. Irfan Ali.
Irfan Ali, sir.
He's on the phone call.
Kindly off this of the
Irfan Ali, sir, kindly stop presenting, sir.
You can off the presentation so that we can go to the next. Because Dharmaraj is on the line.
Yeah, okay.
Yeah, now, yeah. So now I can upload. So, are you able to see the screen?
Yes.
The screen of the presentation slide?
Yeah.
Okay. So, I'm happy to be giving an invited talk here. And before that, let me find out who are all the audience, what is their background. So that way it will be easy to make out if at least one or two audience, they say that what is their background, then it will be easy for me to go in that direction. Anybody can make out their background, please?
Most of the statisticians are with war backgrounds.
I am Dr.
and statistics.
Okay. Yeah. So one audience is please go ahead.
Yes, sir. Sir, I am Dr. Irfan Ali, and I am from Department of Statistics. So my background is statistics and optimization. Both. I have both backgrounds.
Okay. And thank you, sir.
Management is also there, sir.
Okay. And any other wants to say, give a self intro? Anybody is interested to give a self intro of yourself as audience?
Yes, sir. Sir, I'm Dr. Irfan Ali, and I'm from Department of Statistics and Operation Research, Aligarh Muslim University. And presently, I'm working on optimization area and application of optimization in statistics, basically.
Thank you. Anybody else?
I'm Dr. Prasad from postgraduated from SOU PG Center, Kurnool in Operations Research and Statistical Quality Control. And now I am teaching statistics for UG students for the past 38 years.
Okay. Thank you, sir. Thank you. Anybody else wants to give a self intro? Okay. If no one is there, then let me start my presentation. So first, let me recall Professor C.R.RAO, and we should be proud to say that we are in the same era in which Professor C.R.RAO is here, and kindly go through his credential and his contribution to the whole country as well as to the whole world related to the statistics. And those who are teaching statistics courses, you may be knowing many of his contribution, but still those who are not aware of it, please go through. Therefore, this is a time we should recall his contribution to the statistics as well as to the other related areas. As far as today's my talk is concerned, I am going to give talk on the Markov regenerative credit rating model, and for that you should have a little bit knowledge in probability and a little bit of knowledge in financial mathematics and a little bit of knowledge in stochastic process. And without statistics, you cannot do anything related to any predictive analysis. Therefore, of course, your statistics knowledge is also needed. So those who have probability, statistics, stochastic process, and this financial mathematics, one can able to understand my talk. And this talk is already given in some other places also, but still this is one particular research article with my students. So you can go to my website and you can download the paper, and then you can get the complete idea about the paper also. So with that introduction, let me start. So by the way, I'll ask Professor Anand Chari how much time I have a limit, so that I should finish it before that. Sir, unmute. Sir, unmute.
Professor Dharma, as we can go till 12, 1:30, 1:15, so that we can break after lunch.
Okay, sir. Because I'm starting in extra 15 minutes. Therefore, okay, I'll complete it before 1.
Yeah, here and there about 5-10 minutes up to 1:30 would have been a very idea. Better that you can complete. No, please.
So I will try to finish it before 1.
Yes, yes. Thank you.
Okay. Thank you, sir. Thank you. Thank you, Professor. So with that introduction, there are only 25 slides. It won't take much time, but let me give some idea to you, so that those who are starting the research in the financial mathematics, or those who have already done, people can unmute. So mute, therefore there is no voice coming back again to me. Yeah. Others can mute, therefore there is no voice. It's echo I'm getting.
Almost, I think everybody.
Anand.
Yes, sir.
Yeah.
Sir, Anand sir, kindly mute.
Yeah.
Yeah. Thank you. Yeah. Now I'm not getting any echo. Thank you, sir. Thank you. So, so my plan is to give some introductory idea about the modeling and related to the finance. Okay? So this slide consists of what is the meaning of credit risk, and why do you want to do the modeling, and what are all the different modeling one can do. And in this talk, I am going to emphasize on Markov regenerative process modeling, and what was the modeling we have done it, and how we got the results, and finally the reference. So that's the way the presentation goes. What is credit risk? So you would have seen the risk is attached with many things, including credit. The risk is many of the things. The day-to-day life itself, we are many activities which we are doing is with the risk. Even today's presentation also with the risk attached with that, whether my computer works or whether the networks works, or the other side networks, and you are able to sit down and listen. So there is a risk attached with the whole process. Similarly, you can think of in the financial asset, there are many things you assume. You cannot assume that it is going to be always 100% going to be in a fruitful situation. Whenever that fruitful situation changes, then it is a risk. So the risk can be analyzed in many ways. For example, the people who have a quite good knowledge in the management side, they may do the risk analysis with a little bit of mathematics and more of data oriented, then it is going to be called it as a time series risk analysis. But if you have a little bit of probability knowledge and stochastic process knowledge, then one can use your probability and stochastic knowledge to do the risk analysis related to the credit. So in this particular talk, I'm going to talk about the only credit risk, not any other risk. There are many more risks attached in the whole financial mathematics itself. So we are just discussing only related to the credit. The credit, the people who have gone through the credit, you would have seen it. It may be in the different level. So anybody can able to say what is the credit rating. Anybody can able to say it in the chat box. You can write down in the chat box what are all the credit rating you know in a real situation. Can you write down in the chat box? Can you write down some few letters? What is the meaning of credit rating? Or can you give a one particular stock? What is a credit rating? Anyone can write down in chat box. I'm just opening the chat box. I'm seeing that anybody can able to give what are all the different ratings for credit or any particular asset or stock or any product. Have you come across any credit rating points? If you come across, you just write down in chat box. That for you, I can make out of these things at least one person knows the credit rating. Somebody can write down in chat box. Any one particular one rating. Then the further things you can able to understand. That's what I am asking you to the audience. Give a one example of one rating. Any one rating. How it is specified. Anybody is writing in the chat box? Okay. So it looks so nobody can able to think immediately what is the possible rating. Have you come across the rating called the AAA? At least you can say yes or no in the chat box. AAA, AAB, ABB, BBB, BAA. Anybody come across those ratings? This particular product is in the AAA. Now it went down. It went to the AAB, or again it moved down. It went to the B or BBB. Anybody come across these ratings?
Yes, sir. These are the credit ratings by CRISIL and all for the organizations.
Great, ma'am. Great. I'm expecting at least one audience able to say that what are all the possible ratings. Correct.
Yeah.
So this is what I'm going to talk about in today's talk. Thank you. Thank you. Now I move to the next slide.
Sure.
Yeah. So this credit risk, that's what I'm saying, this level. The level means that is a one level. AAA is the one level. From there it moved to the different level and so on. And it is completely a stochastic. That means you never know tomorrow what is the rating is going to be for a particular product. It may increase or it may decrease. Or when we use the word decrease or increase means it is having a better rating or not good. And finally, if the product is completely a down state, then it goes to the default. So the default is the one of the states in which the product is completely down. So that is the way the credit level is measured. And we are going to analyze the credit rating with the nice stochastic process. Right? I'm not going to read out whatever I have written here. Therefore, you just understand yourself. And yes. So now we are going to do the modeling. Modeling, there are many ways. Modeling means you understand how it works. Then you mimic that behavior of the system, how it works. Then you make a mathematically write the governing equation and so on. Then that is called the modeling. And after you model, you have to analyze. And after analyze includes you verify how it works. If it does not going well, then you update the model, or so it's basically a sort of triangle: modeling, analysis, and verification. Then after verification, you again modify the model, then you do analysis, then you do the verification. So it is in the form of a triangle. It will be keep on improving the model till you are able to get the result which modeling. And what we are going to do, the one particular type of modeling in which we are able to use the stochastic process, and using a stochastic process we can be able to conclude what is the probability that so and so product is going to be down the time. It's a predictive analysis. That means as on today, this is the way the rating goes, and if this behavior continues for some more time, what will happen in future? That's it. The problem is so simple. It is called a predictive analysis. So using the nice stochastic model, we are going to do the predictive analysis. In that, automatically you use the distribution and things like that. There are many research work already happening in this direction, and they make it as a state space. So this state space 1 to k, you can make it k is a one particular label, another number, and so on. So it's always a finite number of states. So all the different rating you can make it, and you can make it a k is a default rate. That means 1 is the best rate, 2 is the little down, and so on, and the k is the lowest rate, that is the k. So there are many ways people started working in this direction, and there are some flaws in it that I am going to make out. So these are all the flaws. The flaws is you cannot apply the Markov property. That means it is called a memoryless. You cannot say that the memoryless property satisfied at every stage, therefore future depends only on the present, not the past. This Markov property or memoryless property cannot be the correct way to do the modeling. So earlier literature, they used the Markov assumption, therefore they got the result. Then we figure it out. We should not use the Markov behavior. Why not? You can improve it. So that also have done it. And not only Markov property, the distribution which you attached with the time spending in any state. That means for particular product, it is in the AAA. How long that is going to be the AAA move to any other state? You can make a very easy assumption of exponential distribution. But if you use exponential distribution, you have memoryless property, then things will be easier. But actually, it is not going to follow always an exponential distribution. Most of the time, it may be a non-exponential distribution. That means it will have a aging, and even it moves to the different state, how long it was in the previous states also sometimes matters. So there is a time dependency is matters, and the aging is matter, and the memoryless property has the no aging. So it is a memory full. That means the memory is there as well as the time dependent is there and the non-Markovian. So things are going to be complicated. So that can be visualized or that can be modeled nicely with the Markov regenerative process. That's what I'm just developing a story. Why do you need a Markov regenerative process? To take care of this, that is possible. So still there is some non-Markovian setup. There is a wide group that is called the D Amigo. In this group from Italy, they have done quite good work in the non-Markovian setup also, but they have not captured all the whatever the deficiency which I said earlier slide. They have not taken all. They have taken few. That means they have landed up from a Markov model to semi-Markov process model. But our contribution is myself with my students. That contribution is basically moving from Markov process to semi-Markov process. Then one more level, that is called a Markov regenerative process, in which all the three issues are taken care at one stage. Whereas this earlier literature also handled non-Markovian, but they have handled non-Markovian at each one logic, not all three. What is a Markov regenerative process? So it is nicely can be given. It has a dependency at not at every stage. There will be a completely independent concept will come whenever something is required. I can give you one simple example. When some students register the courses in every semester, they register more than 5 or 7 courses, and they remember all the courses till the final exam is over. Once they get the grade sheet, then they forget most of the time. Then they started the new semester with the new courses registration and so on. So I can say whenever they start the new semester, that day they forget all the previous things. Even they have some memory about the things, but what I'm saying is related to that courses they registered. They forget all the previous things. They remember whatever they registered till they write the final exam. So that means that is going to be a one cycle. So that is called the global kernel. So in the Markov renewal process, the renewal happens. That means all the previous things are erased. That means once you get the CGPA or once you get the percentage, your next semester percentage depends on the previous semester percentage and how you have done it in that semester, not previous to previous semesters. That means every semester your grade sheet will follow a global kernel, and within that that period, one period, whatever you do is it may be in the different state, but still the memory will be there. Therefore there is a time dependency, there is a aging, there is a non-Markov property, and the Markov property is satisfied whenever that cycle completes. So the cycle follows the global kernel, and within the cycle it is called the local kernel. So it is a little difficult to understand these all the slides, so you cannot understand in 1 minute. So those who are interested to want to study the Markov process, semi-Markov process, Markov regenerative process, you can always go to my website and read some of the papers, and you can read the related paper and understand. So I'm just saying in an easy way. I'm going to show nice one slide in which, yes, this is a slide. So this is a slide in which you can have a connection between discrete time Markov chain and a semi-Markov process and a Markov regenerative process. In the discrete time Markov chain, whenever the system changes to the different states, the Markov property is satisfied. In the semi-Markov process, it is same thing, but the time duration in each state, that is a non-exponential distribution. But in the Markov regenerative process, it is not only non-exponential distribution in the time spending. The Markov property won't be satisfied when the system changes to the different state, but whenever it is that cycle is completed, then that point the Markov property is satisfied. Then till the next cycle comes, the Markov property will not be satisfied, even though system moves to the different state. So why I am saying this story, that is related to the credit rating. When the credit rating is a AAA, even it goes to the different state, some state you may have complete memories erased. That means that cycle completes. Still, then the system moves to the different rating, and whenever some particular state it reaches at some time, then all the past history is erased. Therefore, you cannot make a discrete time Markov chain for this scenario. You cannot make a semi-Markov process. You have to use the Markov regenerative process. That is a very closest model than the discrete time Markov chain and semi-Markov process. So we have used the MRGP, in short, Markov regenerative process, and we have identified the global kernel and local kernel, and there is a nice theory in which how you can get the probability of a system being into the different state over the time. That can be computed nicely. It's well defined concept, and once you understand how you can map the Markov regenerative process with the credit rating modeling, then you frame the model nicely. Now you see that the person who answered, so this is the possible ratings. AAA, I am just giving a 8-state rating. It need not be 8 state, you can go for more state. But the problem is, if you have a more state, then you should know more information. That means you have to estimate the parameters of those things. So more you make a complicated model, the problem is going to be in the estimation side. So this is a 8-state model, and the D is the down state, and this is the best state. So the system will be keep moving into the different state. And let me, I don't know whether I have that diagram of, yes, I don't have that state transition diagram for nicely how the system moves to the AAA to A, and so on. Once it goes to down, it won't come back. So the scenario is how the system is starting from some state and reaching the down state. What is the probability of it? That we are doing, that we are computing nicely, and yeah, we can able to, the way that one audience was telling, you can able to get the data from Standards and Poor's, the true data. You can get the true data for so many years. Then once you get the data, then you do the empirical analysis. You estimate the parameters involved in whole modeling. Because when you do the modeling, you say that this is a parameter. Then somebody has to give the value of the parameters. So that is comes from the data side. So you take the data of past some 10 years or 15 years data, then estimate the parameters, whatever you want it, then plug that parameter values. So numerically you go for predictive analysis. That means you say that if you use the semi-Markov process model, and if you use the DTMC model or real data, how it works. So that means you do the predictive analysis. Suppose you have a data of 15 years, you use the 10 years for analysis purpose, and the next 5 years you use it for the verification. That means this diagram gives as the actually you do the predictive analysis with the last 10 years data, and you do the prediction, and the prediction by the semi-Markov process and MRGP, and you have already a data. Therefore, how actually it goes, that also you plot. Then that is that SMP. So then you compare all three. That means the real scenario and your predictive analysis using a semi-Markov process and the Markov regenerative process. Then you compare. That shows how much your Markov regenerative process model is closer to the real scenario. Even there is a small deviation in it. Now you predict another 10 years or another 1 year. Then whatever the recent actual SMP data, you compare. That way you keep on improve your model. That means you estimate your parameter better and better and get the result. Finally, you can do the hypothesis testing, whether because you have done it with the verification with the data. Therefore, you should do simple statistical analysis, how much error is going to be minimized comparing to the SMP and MRGP. Whether the error between SMP with the real data or the error between MRGP with the real data, which error is going to be less. Obviously, the error with the MRGP with the real data has to be less, then only whatever you put the effort of creating a model is worth it. So we do the little testing of hypothesis with the related to the error. Then we verify that it works well with the 99% confidence level also. There are nice references. When we started this work, we have started this work sometime in maybe some 6 years back. Once we started this work, then we started seeing the literature. Then there is non-Markovian in the beginning. Then we identified there is already a we started working on it. Then we have this team had a quite good contribution. So we improved. Yeah, you see that there are many more papers with the same person. So we have improved his work, and currently we have made 2-3 papers with him also. Therefore, we are able to improve as much as possible in this line. Now we land up not only MRGP process, because this result was like some back result, and removed some assumptions, and we got a better results in this direction. So those who are interested in credit rating, to my website, and I think you may find some 5 to 10 papers in that. Then you can understand what are all the things which is useful for you. You can pick those papers and you can read. I'll answer any of your questions that will be worthy instead of me speaking till the end. Please, any questions I can able to answer.
Yes, sir. I am Monisha. I am from Infosys actually. So just wanted my thank you for your information. It's quite learning for us because you have explained quite in detail, and would really like to go through all the papers as well. Just one question I was having
There is a one echo, ma'am. I think Professor Anand Chaudhary can mute. Yes, ma'am. Please go ahead.
Yeah, sir. What I was saying is it was quite informative, and would definitely like to go through other papers as well. We'll look into your websites. Just one query I was having: how do you, I mean, S&P and CRISIL and all the credit agencies, you get their data and then you do the analysis, or how do you basically get the data from?
Okay, ma'am. It's a good question. See, initially we don't have a data when we started this work in the beginning. Then we realized we should have a actual data. So for that we put effort, and our institute also agree for that. And there is a website. There is a called the Thomson router, and there is a huge amount per year, almost 10 lakhs. And you have to pay, and they will give a real data to give a login. Therefore you can able to use the real data, and every year you have to what you call it as renew. And we spent a lot of money for getting a real data, and still we are using that facility. So it's credit goes to the IIT Delhi.
Yeah, okay. Thank you, sir.
And without the real data, one cannot do this work. Either you should have a collaboration with one so company, then it is possible. Otherwise, you should be able to buy it. So we don't have the collaboration, but still we have a other collaboration for the data. We ask the institute to get it done, and now also we are having a real data with us.
Yes, sir. Paid service kind of.
Yes,
it's a paid data. Okay.
Yes, we pay. Therefore, they give the login. Therefore, we get the real data. And our not only my students, many of our students, they use it, getting the real data for the verification purpose. Because I am doing this type of verification, whereas the students from the differential equation side, they are numerically doing some stuff, and they also verify with the real data. So we have a stochastic group, non-stochastic group. So whoever wants to do the predictive analysis related to the finance, then for verification purpose they use the real data and they verify it.
Okay, sir. Thank you.
Being a head of the department, I know how things going on with different direction. Yeah. Yes, ma'am. Any other question? Yeah. Yeah, anybody else wants to ask the question? Professor VIBHUSHAN?
Any other questions?
Hello. Anybody has any?
Okay, if there is no questions, we'll thank the speaker. Thank you, sir, Professor Dharmaraj, sir, for being here and sparing your valuable time on the Sunday here. And also, we thank our chairperson, Anandraja sir. Thank you, sir, for being here.
Yeah.
Giving your valuable time.
Thank you, sir. Thank you. Thank you.
Thank you very much. Thank you.
I also thank Professor Irfan Ali, sir, for being here, delivering the lecture here. Thank you, sir. With this, we come to the end of our morning session. In the afternoon, we meet by 2 o'clock.